pakai mic sekali-sekali kan, jadi balikkan sehingga arena Elimina pula kan. Okay. So diorang punya tajuk projek diorang, abang nampak diorang punya akan jadi orang yang terkaya di Malaysia lepas ni. Mungkin seorang pakai Lamborghini, seorang pakai Lamborghini tu, right? Okay, sebabnya diorang nak buat satu produk di mana diorang tengah lukis tu, jangan jauh. Diorang tengah lukis printer yang boleh pakai X ataupun pakai duit. Maknanya pergi vending machine. So kalau kata tiba-tiba orang dekat mana-mana kan, pergilah Jabatan Pendaftaran Negara, tiba-tiba dia minta, boleh tolong printkan IC awak yang lama. Tiba-tiba minta, tempat printer tak ada, diorang pula orang tu tak bagi. So kalau ada benda tu sendiri, diorang akan start printing dekat situ, faham? So this product memang nampak komersial yang paling tinggi, lagi-lagi kat tempat sekolah, lagi dan sebagainya. So apa yang abang suruh diorang buat adalah lukis apa bayangan 3D printer dan bentuk diorang tu. Nampak? Jangan tanya dulu, jadi kita tanya. Faham apa projek dia tadi? Printer pakai tu, alright. Okay mak, bang fikir bang bagi nampak printer, bagi nampak kaki meja ke, bagi nampak ada tayar ke, ikut abang nak letak apa. Bagi lukis je, mana yang abang nak. Lukis je, tak ada apa. Ini sketching kita panggil. Bang, keluar kertas yang lain ni kat mana? Masuk duit punya slot kat mana? TV. Akun TV. Okay. Lagi? Apa dia? Agak-agak. Okay. Alright bang, tak apa. Ini puas hati. Bagi dulu. Yang goyak. Okay, bagi tepukan. Apa yang abang nak korang tengok tadi, adik-adik tengok, nampak tak dia macam apa benda nak buat dia macam confused, terkiat-kiat sebab dia tak pernah dengar tempat masuk duit macam mana, printer macam mana. Kalau dia tahu printer tadi, dia lukis tak printer? Lukis tak? Kalau dia tahu tempat isi duit, dia lukis tak? Dia tahu. Kalau dia tahu struktur, dia lukis tak? So hari ni abang akan ajar cara macam mana nak buat benda ni. Itu cara fabrication dia. Okey. So besok adalah cara untuk electrical dia. Faham? Okey. So balik kepada slide ni. Saya boleh tekan down kesian dekat ni, saya lama-lama kurus nanti. Tulisan.
Apa range lebih naik?
Tak boleh bully. Okay, final project Zull design Asif dia memang dari lain saja. Itu nama saya lah, nama abang. And then kita diberi tajuk, Employing Mechanical Standard Part in Final Year Project Design. Okay, first saya kita pergi kepada pengenalan. Sebab saya buat benda ni bahasa Melayu lah, supaya semua orang faham. Dan kalau ada apa-apa nak tanya, kalau boleh tanya dalam bentuk bukan teknikal. Sebab sometimes saya tak berapa faham apa yang awak maksudkan teknikal tu. Kalau nak lukis pun boleh. Okey, pengenalan. Pembuatan selalunya di bengkel-bengkel ni merujuk beberapa kriteria lah. Antaranya yang pertama yang abang titik beratkan adalah reka bentuk. Nampak tadi yang dilukis tu? Itu adalah reka bentuk. Yang kedua, pemilihan bahan dan komponen. Lepas dah ada design, dah pilih apa design yang kita dah confirm, kita akan masukkan kat dalam kita punya design tu. Apa barang yang kita nak masukkan. Okey. Yang ketiga, pembuatan dan verifikasi. Bila kita dah ada design, kita dah ada barang, baru kita start buat. Faham? Alright? Itu inilah dia punya proses. Dan yang keempat adalah pengujian dan kelima pengupasuaian. Biasanya pengujian dan pengupasuaian ni berlaku apabila lepas kita siap, kita test tak jadi, kita nak kasih jadi lagi. So macam mana dia punya proses ni. Okey, ini apa yang nak cerita hari ni, daripada pengenalan ni dan dia punya kriteria tu, kita akan go one by one. Okey. And then kita akan duduk untuk buat siap satu projek. Macam dia punya tadi, kita akan siapkan apa komponen yang dia perlukan. Maknanya seorang nak tunjuk kat mana nak set komponen, kat mana nak Google kat mana nak apa benda semua yang korang nak cari. Okey, kita teruskan dengan yang pertama. Ini adalah reka bentuk terbahagi kepada dua. Pada abang, reka bentuk terbahagi kepada dua je. Senang cerita lah. Untuk dibasickan atau diasaskan kepada dalam program awak ni final year project. Ini dua reka bentuk yang paling simple, basic untuk program awak diploma untuk ni. Kalau nak pergi kepada industri, ada banyak lagi dia punya reka bentuk design-design ni. Okey. Dan yang pertama adalah lukisan cadangan. Yang kedua adalah lukisan kejuruteraan. Ingat dalam kepala sampai bila pun. Kalau kata lukisan cadangan, kebiasaan dia kita pakai apa? Pakai apa? Pakai apa? Tangan dan pensel lah. Kalau pakai tangan saja tak ada lawan pun. Okay, so dari itu kita mencari idea dan konsep. Biasanya kita nak cari idea awal-awal. Kita main langkah-langkah. Macam tadi, brother Daniel dan juga brother M. Kan? Apa nama? Kan? KHAI. Oh, okay, kan faham. Right. So, yang ketiga kita mengenal pasti mekanikal kita. Okay, ini biasanya point-point abang nak roughly terangkan apa benda yang korang dapat lah. And then untuk lukisan kejuruteraan, okay, ada dua cara Lukisan kejuruteraan ni kita boleh buat mula-mula nak buat projek ataupun selepas nak buat projek. Macam abang biasanya bimbing pelajar-pelajar yang buat projek ni, abang akan bagi lukisan cadangan je, dan dia orang buat, dan dia akan belajar bagi lukis. Faham? Sebab short time. Sebab hari Jumaat satu hari nak kena datang, nak kena buat bengkel, so tak sempat. So abang just roughly untuk dia orang je, bantu untuk macam mana nak buat, macam mana nak buat. Dan kalau kata you all boleh buat lukisan kejuruteraan dulu, you all akan jadi 2 kali je. Itu kalau kata ada perubahan lah. Kalau tak ada perubahan, 1 kali je lah. Kalau kata betul-betul dan detail. Alright, so lukisan dengan penggunaan software 3D atau CAD, pemilihan komponen yang sesuai. Maknanya kalau dah ada komponen yang sesuai, baru kita buat benda tu. Faham? Okay, kat sini pakai Inventor Fusion software apa? Software apa pakai? Inventor. Siapa yang pakai Inventor kat tangan? Angkat je tangan, abang tak panggil. Ramai. Yang paling tinggi ke depan. Siapa paling tinggi? Ada. Tarikh. Siapa paling tinggi? Semua tak mampu lah. Abang, okey, boleh. Berani ke depan. Mesti tak decide lagi. Okay, abang tinggi dulu. Dia dah ada. Tapi ada tak apa-apa idea yang tak start sikit? Ada juga. Siapa lagi? Lagi tinggi. Abang bayar bang. Abang tidak layan abang. Siap abang. Dah. Alat ada. Okay, bagi. Kita tak pakai boleh juga kan? Okey. Nama? Daniel. Tanya. Ini juga awak yang ini. Alright. Okey, so ada apa-apa idea yang dah start sekian? Takkan tak bisa tak di sini. Tak, orang tak lagi. Okey, tak. Antara 3 kan. Ada yang dah fikir tak kenal kan? Tadi. Apa tajuk? Faham tak? Kalau kipas siling tu kita pusing laju sampai 65, kita letak tangan kita, berhenti tak kipas tu? Berhenti. Tetapi kalau kipas tu, motor dia tu abang modify, letak ratio yang tinggi, daripada dia pusing laju tu dalam contohlah 2000 rpm, dan abang buat dia jadi pusing 2 rpm, sangat slow. Awak boleh bergaya kat situ, dan awak tahan pun tak boleh tahan, sebab abang dah kuatkan top dia. Boleh faham? Itu function gearbox. Dia reducer tetapi increase the top. Boleh faham? Okey? Sebab tu naik gear, siapa naik kereta racing di sini? Kalau naik bukit pakai gear apa? Ha? Naik bukit. Paling-paling tidak paling sikit yang 2 lah, tarik sampai 120 lah. Faham tak? Sebab apa? Sebab nak pick up dia. Pick up. Cuba pakai yang 5. Faham? So itulah function dia apa. Dia nak pick up kan ataupun nak bagi torque tinggi. Okey? Boleh faham? Ini contoh potong-potong dia buat sendiri. Ini besi hollow setengah inci ni. Mana mau berapa ni? Ini besi hollow setengah inci. 3 suku. 3 suku inci ni bersamaan dengan 19 mm. Lebih kurang 19 mm. Boleh faham? Okey. Right? Okey. So, itu sedikit video. Dan apa kita nak tengok? Okey, ini yang abang nak tunjuk. Brother tadi buat tadi. Nampak tak? Abang ada satu projek ni dulu. Namanya dia panggil Concrete mixer. Berapa campuran mixer, berapa campuran tu, faham? Okey. Sekejap abang cuba cari ke mana. Ingat tak? Okey. Apa? Okey, brother balik ni study benda ni, faham? So, kalau dia tak bagi abang tadi, abang tak panggil dia tahu tak apa benda nak buat dengan benda tu? Dengan dia lukis tadi. Kalau kata dia lukis tadi macam tu, dia tak tahu benda kan? At least hari ni dia dapat sikit ilmu. Okey, dalam tu brother hingga tadi buat benda tu, yang dalam tu. Tengok nampak tak? Betul tak baja macam ni? Awak cakap tadi baja awak betul-betul biji-biji, betul? Right? Dia akan dibawa oleh skru yang brother tadi buat. Faham? So kita boleh buat sendiri skru dengan benda tu, dengan harga yang murah. Kalau di pasaran 2,000, 3,000, 4,000 harga dia. Boleh? So maknanya bila pergi kepada programming, boleh faham bila pergi kepada programming, dia kena buat berapa saat motor tu nak bergerak. Okey, boleh faham? Nampak tak? Nampak? Okey, abang tulis balik apa yang kamu buat tadi. Motor tu pun boleh pakai. Faham? Tapi tak boleh banyak sangat lah, nanti dia stuck. Dia tak berapa kuat, tapi boleh pakai lah. Right? Bila ada sensor dekat sini, sensor ni detect cakap tak cukup JP contohnya. Macam mana sensor ni nak detect bang? Mana saya tahu, awak tanya yang besok. Lubangkan pipe atas ni, buat corong tempat masuk, buat satu pipe macam ni. Faham? Pernah tengok water pump? Okey, ini water pump 12 volt water pump. Tak payah yang besar-besar, yang kecil-kecil pun boleh. Ini je. Pernah tengok ni? Dekat dalam kedua rumah kita. Pernah tengok? Boleh pakai. Faham? Maknanya letak pump ni dekat dalam ni, keluarkan pipe, pergi sini. Faham? Dia pun sama juga. Saya tak cukup air 2%. Kita agak-agak je lah buat programming. Kita buat timer 2 saat. Maknanya kita estimate, kita assume 2 saat bersamaan dengan kenaikan 5%. Faham? Itu kita yang buat sendiri, jangan risau. Kalau pendek tanya ke apa ke, awak tunjuk segala fakta apa benda air yang laku-laku. Janji ada nampak. Faham? So itu benda yang awak akan buat. Dan yang ini nak pergi kepada pokok-pokok. Okey, pump juga. Ambil yang besar sikit. Kita panggil dia Okey. Ni kalau kata siapa belum follow, boleh follow So ada nombor dekat situ. Dekat FYP Zull Design Instagram ada nombor. And then kalau nak tengok contoh-contoh projek, ini abang buat satu segmen secara percuma pada waktu bikin. Dia motor apa? Okay, right. Dia pakai motor ni. Motor 250 watt, 24 VDC atau 12 VDC. Ini. Tapi boleh cari kat Shopee. Abang pakai motor ni. Tapi ada gearnya.
Number.
You see the price
Ini adalah motor dia. Kenapa abang pakai motor ni? Tapi ini laju. Tapi untuk yang remote kecil remote kecil
Apa?
besar mana mesin rumput?
Bukan nak buat mesin rumput.
Okey. Alright, kalau kata motor boleh pakai motor ni ataupun motor power window kepala petak. Motor power window kepala petak ni macam mana bang?
Macam tu.
Bukan kepala dudu
Apa? Koyak sikit tu.
Alright. Kepala petak. Alright. Okey, abang pakai ni motor power window kepala petak. So kalau kata kenapa abang pakai kepala petak? Tengok ni. Nampak tak ni? Tak. Ni, nampak ni? Ada shaft itu, shaft dia petak. So kalau ada lagi satu yang macam ni. Yang ni jangan pakai. Yang ni susah nak mounting. Sebab kepala petak abang jual sekali dengan dia punya bush. So kalau kita nak mounting shaft ke, nak tambah panjangkan shaft ke, nak letak tayar ke, senang. Alright, boleh. Okey. Cari yang ini. Dia ada kiri, dia ada kanan. So abang untuk mesin rumput, abang pakai motor ni. Okey, boleh.
Ni mesin semua baju tu.
Ya.
Ni pun nampak ni motor dia ni. Sabar je lah. Tu motor yang dekat mouse sama dulu kat cursor tu. Tu motor power window lah tu. Alright. Boleh. Ada soalan lain?
Enggak. Mudah.
Bagus.
Add to cart. Buy now.
Tak apa kakak, janji nampak betul je. Macam tu je. Tak payah, at least nampak dua line. Tak tiga pun tak apa. Sebab okay, right, good.
Yang PP pun tak, yang dekat kamera tu. Ni lepas ni ada kerja lagi.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Very good morning everybody. Okay, so sorry about we had to do a little bit of housekeeping. So I'm going to basically mix around between Bahasa Malaysia and also English depending upon which is suitable. Yesterday I was basically struck down by food poisoning. So last night was not very good for me. So today I'm a little bit groggy and edgy a little bit. So I was asking one of the committee where is the nearest toilet actually. So if I have to go out, basically, okay, at the back, right? Okay, and then so excuse me if I have to do that. So hopefully I would not have to do that during these 2.5 hours in front of session that we have together. Okay. So welcome to the workshop. Application of Microcontroller Internet of Things for final project implementation. You have a little bit, your title is a little bit about IR4.0, still about final year project implementation. So today, kita nak berkongsi lah dengan semua tentang basically idea idea dalam kita membuat final year project. I believe most of you are in semester 4 and 5 of your diploma program. So maybe you are already chosen a title, or in the midst of choosing a title, or you are in semester 5 doing your FYP already, and maybe you can incorporate something that you learned today. Because in my point of view, dalam pendapat saya, yang paling penting sekali ni adalah kadang-kadang kita, benda yang kita tak tahu, kita akan jadi takut. Kita tahu, ni Internet of Things ni, IoT ni very difficult, susah ni kan. Pasal kita tak tahu. Kita tahu mana nak mula, itu yang paling utamanya lah. We don't know where to start, we don't know what to basically look at or find in the internet and things like that. Okay, so hopefully today I'm not going to turn you off from 0 to hero in 2.5 hours. That is not possible. But at least you have some understanding of what is IoT and what is basically the concept about IR4.0, and give you a little bit of an idea of how to approach a final year project. Okay? Alright. So when we talk about IR4.0, this is basically what is happening. You have your first industrial revolution, second revolution, third revolution, and now they are saying that we are in the fourth industrial revolution. Okay, the first industrial revolution where mechanization basically started, and then you have the second one, which is mass production of cars. Ford was the first one. Cater Ford, mass production. That was the second industrial revolution, and then you automate. Robotics, automation and things like that comes into play. Then you have your third, and now we are talking about benda-benda semua menjadi digital, right? IoT and things like that. So now we are at the fourth industrial revolution. Some people say we are already at fifth industrial revolution. Okay, so when you look at IR 4.0, these are the main pillars. Ada 9 pilar dalam, ada 9 tiang dalam IR 4.0. Yang berkait dengan kita, terutamanya mechanical, adalah basically autonomous robot, automation, and then a little bit of additive manufacturing, AI, big data, and also IoT lah. Big data not so lah, but big data and artificial intelligence is basically interrelated. But when we talk about mechanical, we are talking about automation. Benda nak jadi automate, right? Dia benda boleh bergerak sendiri, melakukan itu sih tanpa melibatkan manusia. So nowadays, you jarang lah boleh stand alone. Electronics, electrical, mechanical. There's no such thing as stand alone right now. Right? You must have kata orang tu the ability untuk cross multi-discipline. So advantage dia definitely bila we talk about mechanical plus electronics, not electrical, electronics. Okay, then you can basically create automation, the mechatronics of things. Okay, kalau you tahu mechanical saja, it's not going to serve you well when you graduate and things like that lah. And project you kalau mechanical saja, is tak ada wow factor di situ. Okay, so kalau project mechanical you tambah dengan a little bit of control element, microcontrollers, electronics, project you akan jadi wow lah. You are at the, saya punya background is biomedical engineering. Okay, so I merge electronics and medical, and I punya master is mechatronics. Okay, so basically, from my point of view, you lebih beruntung pasal orang elektronik bila dia buat FYP, bila orang elektronik buat FYP, electrical buat FYP, dia tak ada ilmu mechanical. Sometimes if you want to complete a project, kalau you nak buat project tu yang complete, dia mesti ada mechanical aspect. Mesti ada mechanical. Robotics pun ada mechanical aspect tu. Ada kena design dia punya arm lah, apalah, gearing lah, things like that. Budak electronics itu akan menjadi satu isu besar bagi dia lah. But you in mechanical, that is not your issue. Your issue is nak tahu electronics. Dan yang advantage untuk you adalah bila you masuk electronics, there are a lot of things dalam electronics yang dibuat khas untuk orang yang bukan electronics. Contohnya Arduino. Okay, so contohnya Arduino tu you boleh pick up in 1-2 hours. Dengan hari ni kita akan tengok Arduino, you can pick up easily in 1-2 hours and then you can basically do your first project. Tapi untuk budak elektronik belajar CAD/CAM, buat apa semua, that is going, tak ada software yang semudah itu untuk memastikan. Google SketchUp tu adalah kan, but not that quite ni lah. Okay, so you are at an advantage to incorporate electronics dalam you punya FYP kerana there's a lot of easy to use software untuk orang yang bukan electronics belajar tentang electronics. So that is your advantage. Whether you nak guna atau tidak is depends. But I think you punya FYP, I think most of your lecturers pun would want you to incorporate some electronics control element programming dalam you punya FYP. I think so. I would believe so. Right? So that is where your element of wow factor comes into effect lah. Okay? Right. So we basically when you talk about IoT, there's a lot of activities yang saya sendiri pun pernah buat. Ini pun one of the element yang kita buat. This is we did it with Malaysian Airport untuk basically map out the penggunaan tandas bulanan mengikut bangunan. Right, the water, the sampaikan kita orang kena fikirkan about bau supaya nak jadikan dia basically tak adalah cleaner kena masuk setiap masa. Cleaner masuk setiap 2 jam check, setiap 2 jam check. So kalau bau urine tu tinggi, kita letak gas sensor kat situ. Okay, and then kalau bau urine tinggi, baru dia akan alarm the cleaner to come in. Or you have some automatic option untuk bersihkan ataupun lalukan air and things like that, flushkan ke mana. Okay, so those are the kind of things, termasuklah power distribution, power management and things like that. Manufacturing, ni tak itu saya cerita lah dari segi manufacturing. Now we are going into predictive maintenance of manufacturing. So ni gabungan electronics, gabungan big data, gabungan IoT, gabungan artificial intelligence. Banyak pillar dalam IR4 tu digabungkan jadi satu. Okay. Right, so patient monitoring, muscle sensor untuk patient monitoring as well. Agriculture is a big thing. People are investing a lot of money into agriculture, untuk IoT kan, things like that. Okay, so when you do your FYP, I just want to briefly go through the normal process of FYP because I think that is one of the main title that was given to me in terms of this workshop or in terms of this talk. Alright, FYP. So when you look at engineering process, I think this is more towards electronics, but it's going to be the same for mechanical as well. More or less the same. So definitely you need to define a need, you need to define a problem statement, and your problem statement must be very, very good. So that is where everything basically started. Right? So that is the most problematic thing to basically solve. We have the technology, we have all the things that we can come up with, but without a proper problem statement, kita tak tahu apa yang projek kita boleh selesaikan. Objektif kita tak boleh nak define properly and things like that. So define a problem statement and then do a background research on the problem statement. People will look at literature review and things like that. And then do your block diagram, do your flowchart if you have a program, if you are using any programming languages. Build and test a prototype, test and redesign, and then present your result. The most UniKL last week kita baru lepas e-tech audit. Right, so one of the issue with e-tech audit diploma program kita orang is always the result has no analysis. Result tak ada analysis. Bila kita TVET ataupun kita TVET diploma level is TVET, right? Mostly kita buat projek buat tapi kita tak ada elemen untuk analisa. Kenapa kita result dia tu just kita dah buat satu alat and then siap. there's no discussion of the result, or you nak buat table, graph, apa performance of your ni and things like that. So that is the main problem when it comes to TVET, right? Kita orang punya engineering program pun engineering technology program, so it's a TVET program. At the end of the day, you ada project, working project, okay, but the result is just full of pictures, gambar je. Benda tu working. Kenapa dia work, bagaimana dia work, or any analysis on how it works, nothing. Right? Okay, so that is a huge problem in FYP, in my university. I do not know in Poly. Right? So for example, you nak design bilik ni, I will go into that. I will go into an example. Let's say we want to make a smart room dalam bilik ni kan. Smart room dalam bilik ni, so you just pakai je sensor suhu untuk kawal aircon, you just pakai sensor cahaya untuk kawal lampu, betul? Lepas tu you pasang, you pasang, on kan, siap. Lepas tu benda tu work. Dan result yang nanti apa? Letak gambar sensor. Or how do you want to approach that? Katakan dalam electronics, I would say one of the analysis yang you boleh buat adalah kat mana kedudukan sensor tu yang terbaik. Adakah sensor suhu tu you letak kat depan yang terbaik ke, kat tengah yang terbaik ke, atau kat belakang yang terbaik? Atau you nak letak dekat setiap penjuru part, itukah yang terbaik? So those are the kind of analysis yang you kena buat dalam result. Bukan just pakai satu and then ataupun jenis sensor apa yang terbaik, sensor A, sensor B, sensor C. So you try out sensor A ni performance dia, sensor B ni performance dia. Those are the kind of result that is lacking in the FYP report, right? So mostly people will just go into Google, tengok ada projek dalam Google tu, ambil kan, and then construct, and then siap kan. Sampai kan ada yang saya ada jadi consultant untuk company ni here, my event. Sampai kan budak nak beli barang, student wanted to buy some components, dia siap tunjukkan gambar komponen tu, saya nak yang sebiji macam ni. Padahal kenapa dia nak sebiji macam tu? Pasal dalam Google kata macam ni. So dia tak nak cari yang lain, ataupun dia tak cari yang equivalent, atau dia tak faham tentang there is equivalent or compatible. Dia nak yang tu juga, warna yang macam itu juga, dengan size macam itu juga. Padahal ada banyak lagi option yang compatible sebenarnya. But because they copy and paste, purely copy and paste, they have a problem with that. So you bayangkan dalam FYP report dia, no substance. Dalam result, zero. Just gambar-gambar je. Benda tu working. Snapshot of the thing. Okay? So in mechanical, maybe your design of your gearing system or whatsoever, right? So you test out gear yang macam ni, you test out gear macam ni, apa dia punya significant, or apa dia punya perbezaan, atau apa dia punya efficiency rate and things like that. That is one part yang you have to think about. Okay? Dan normally FYP, you pun tahu, I pun tahu, maybe you dah pernah dengar dari senior you, semua IPDA, semua IPDL sama je. Bila dekat nak ujung nyawa dekat sini, when you are about 1 week away from presenting, that is when you focus on your FYP. Okay, that is normal. Okay, why it is normal? So we need to change that. Okay, so define the need and what your user of your product need. Is it a new version or existing product that has more speed, lighter weight, or lower cost, berat memainkan peranan ke tidak, speed memainkan peranan ke tidak, and things like that. Okay, is it a product with entirely new combination of features? Or so these are where you define the need. But before you define the need, you need to basically find your problem statement first. Okay, and then do some LR background. What is there in the internet? What are other people is going to do, have done on your topic and things like that. Get ideas from these people. When you look at other people, dia buat cara A, dia buat cara B, dia buat cara C, betul? Then you boleh ambil dia punya cara A, B, C, and then you can analyse yourself whether A ni lebih bagus daripada B ke, atau B lebih bagus C, atau macam mana. Or you can basically look at A, B, C and find out where is the gap or where is the pro and con, and then design it on your own. Okay, so you mesti ada block diagram. In electronics you mesti ada block diagram. I'm not sure. Tapi kalau you mechanical, you nak ada element of IoT or controller, microcontroller, things like that, you mesti ada buat block diagram. Okay, and then kalau ada programming, you mesti ada flowchart. Okay, and basically you build and test your prototype. Okay, and as I said, always start with a problem. Okay, so I'm not going to go too far into this, but you get the idea, right? Your problem statement is very, very important. That will then go through your objective, that will go into your methodology, and that will go into your result. It's always a very, very interlinked of subjects over there, right? So sometimes your objective, when your objective is not clear, you yourself basically will not know what to do in your result. Okay. So when we look at the problem, where do we look? Where do we normally look at? What does people spend money on frequently? What are tedious, repetitive, and boring? So those are the kind of things that you want to automate, correct? So I nampak kalau mechanical banyak yang nak buat mesin pokok liku, kan, yang jadi automate kan, daripada orang duk gaul sendiri kan, dia boleh buat pokok liku sendiri kan. Lepas tu nak buat Zull design pun, betul? Zull design pun banyak buat yang membantu Malaysian punya project, betul? Malaysian punya project yang takkan orang putih nak buat solution untuk Malaysian based punya project kan. Benda buat karipak lah, benda buat pokok liku lah, benda buat tu lah, yang repetitive, yang boring. And you would rather see it being automate dan mudah dan boleh mass produce, betul? Okay, something like that. Nak buat dodol dekat nak raya ni kan, siapa sanggup nak pusing dodol tu kan, dan buat mesin untuk buat dodol. Okay, and then how you can combine all the building blocks. Okay, but when you look at, if you want to look at the highest impact, you always look at project yang untuk disability, and then you will see the wheelchair comes in, the blind stick comes in kan. Apa, tongkat untuk orang buta boleh detect obstacle, projek yang berulang-ulang kali muncul, sentiasa membuat kemunculan di setiap kali FYP punya projek. Wheelchair, blind stick, sentiasa buat kemunculan. Kan, saya rasa kita dah tak boleh nak tengok lagi lah benda tu kan. Okay, but kita tak nafikan, we are not denying that those are the high impact project. Kan, bila orang tengok, wah kan, the wow factor, you are helping the disabled, you are helping a child and things like that, so you have that wow impact. Your problem statement has the wow impact. Okay, and basically no other people is due, but this is the main problem. This is the main critical task that you need to decide when you do your project. Okay. Alright. So let me just go straight into basically what we are going to do today, which is look into Arduino or look into microcontrollers. Right. So let's say we want to make this room a smart room. Okay. So you need a controller, which is the brain. You need a controller. And then you should have a sensor to sense the environment. Okay, and then you should have the actuator to basically make it a closed loop. Untuk dia di closed loop lah. Kalau you just ada sensor saja, you measure je. You measure suhu, you measure keadaan lampu. Then you tak ada elemen untuk control or correct the situation, membetulkan keadaan tu, tak ada. So actuators is for you to then have the control over automating the whole process. So let's say in this room, I would want to make it a smart room. Okay, then I will need a light sensor untuk tahu kecerahan cahaya, dan actuator untuk light sensor ni adalah lampu lah, betul? And output dia adalah lampu, input dia adalah light sensor, output dia adalah lampu. So kalau lampu dia gelap, if the light is basically very low lux, okay, it will automatically open up, turn on the lights. Okay, and then another sensor is the temperature sensor for you to control the aircon. If the temperature sensor goes up, detect any increase, then the output there is maybe a fan or an aircon. To make it simpler, let's say a fan. So you can control the speed of the fan based on the temperature that you read. Okay, so you have a sensor and you have an output. And the third one is the most important thing. From your guess, nombor 3 ni apa? Yang paling penting. Bilik ni ada output, ada dua, aircon dengan cahaya, betul? Ada aircon dengan apa, suhu dengan cahaya. Okey, ada dua output, betul? You kena sense dua tu lah. Tapi ada 3 sensor kat sini. Sensor ketiga ni yang paling penting apa? Boleh mengubahkan dia daripada automate kepada smart. Apa dia yang nombor 3? Tak ada. No takers. Nombor 3 yang paling penting adalah motion. Okey, apa maksud saya dengan automation ke smart? Jangan guna ayat smart semena-menanya. Do not use smart, the title smart in your project at your whim. Okay, right? So because kalau lampu gelap, dia terbuka lampu. Kalau lampu terang, dia lampu akan terpadam sendiri. Itu kita panggil dia automated. Ada orang ke tak ada orang ke, walaupun bilik ini gelap, malam, gelap, lampu on, tapi tak ada orang langsung dalam bilik ni, itu pun kunci, tak ada orang masuk. So, can you call it smart? It is just automated. Itu automated saja. Alright? Okay. Dia akan smart kalau dia boleh detect ada orang ke tidak, baru dia buka lampu, betul? Malam, gelap, yes. Ada orang ke? Tak ada orang, tak ada motion. So, buat apa dia nak buka lampu? Betul je lah, melainkan ada hantu lalu ke dan sebagainya lah kan. Okay. So, the third sensor is the most important one, which is the motion. Kalau tidak, you tak achieve objective you. Objective you apa? Your objective will be to reduce the power usage. You want to reduce the power usage, betul? So kalau you nak reduce your power usage, tapi malam lampu tu terbuka dengan automatic, tak guna lah. Lagi banyak you guna power. Okay, baik manual je, betul? Ada orang dia buka lampu sendiri je. Alright, that will be much more safer. That will be much more saving. Okay, so here you can see that you have your 3 sensors: temperature, light, and also motion. That will change your project from automated into smart. Itu pun tak, nak kata smart pun quite iffy lagi lah kan. Tapi boleh lah smart. So when you look back at your project, before you put the word smart, you have to be very careful. Okay, you have to basically differentiate between being automated and being smart. Okay, so you have your light sensor, you have your temperature sensor, and you have your motion sensor, and your output is going to be your microcontroller or your brain, which is going to be controlling the lights and the fan. Okay, right. So automatically, when you talk about programming, so I'm going to give you a bird's eye view of everything first. Bila you decide untuk buat project and things like that, this is the main thing yang you have to go through, the first process that you have to go through. Okay, so automatically, bila you ada 3 sensor, we are talking in just 2 kemungkinan saja. Cahaya gelap, cahaya terang. Ada 2 kemungkinan saja, cahaya gelap, cahaya terang. Lepas tu, kalau suhu panas atau sejuk. Motion, ada orang ke tak ada orang? We are talking about 01, 01, 01 atau 10, 10, 10. Okay, so here we can see that if you have only 2 possibilities, bila you ada hanya 2 kemungkinan, 0 or 1, and you ada 3 sensor, berapa banyak kebarangkalian yang you akan ada, how many probabilities that you will have, automatically is 2 power of 3. You akan ada 8. 2 kuasa 3, you akan ada 8. Okay, so first kali 0, 0, 0. Dekat sini kosong. Kalau kosong maksudnya temperature dia sejuk. Kosong maksudnya temperature sejuk. Kalau room light kosong maksudnya terang. Motion kosong maksudnya tak ada orang. Okay, right. Kalau 1 dekat temperature maksudnya panas. Kalau 1 dekat room light maknanya gelap. Dan kalau 1 dekat motion maksudnya ada orang. Okay, so automatically 2 possibilities, 3 sensors, 2 power of 3. Kalau you ada 4 sensor, 2 power of 4. Kalau you ada 2 sensor, 2 power of 2. 4 kemungkinan. Alright, so when you have 3 possibilities, 2 power of 3, when we have 3 sensors, we have 8 possibilities because it's 2 power of 3. Then you have all these things. This is still in binary. I tak tahu mechanical you belajar tak binary. I think sekolah menengah pun you dah belajar binary ke, numbering system. Okay, so 000, 001, 010, 01, 100 dan sampai 111 lah. All the probabilities that can happen is here. Senang je. Kalau you tengok yang paling hujung 01, 01, 01, yang kedua tu apa? 00, 11. Yang ketiga ni apa? 00, 00, 11. Kalau you ada yang keempat 8 kali 0, 8 kali 1. Okay, is that simple sebenarnya. Okay, okay, so now you nak onkan kipas dengan lampu. Right, you nak onkan kipas dengan lampu. So automatically I akan straight away tengok, I akan terus abaikan kalau motion dia kosong. Betul? Kalau motion dia kosong, kalau motion tak ada orang, motion kosong, yang pertama ni kosong, betul? Ni kosong. Okay, kalau motion dia kosong, ni tak ada orang, betul? I couldn't care less apa yang berlaku kat sini. I couldn't care less apa yang berlaku kat sini. I akan terus offkan kipas, I akan terus offkan lampu. Betul? Buat apa? I tak boleh tengok pun. Alright, so straight away I akan terus saja. Mana I punya ni? Kosong. Betul? I tak payah tengok pun. Okay, I don't need to look at what is happening at the other sensors. Pasal tak ada orang, I just offkan je kipas dengan lampu. Alright, then I will go back and look at yang satu. So motion 1. Okay, motion 1. So this one, temperature sejuk, room light terang, dua-dua kosong, betul? So I can say away 00 as well. Okay, yang ni, so now you have something like this lah. Malah nak pakai pen. Okay, so 1 and then 01 maknanya room light dia gelap, so onkan lampu. Kipas tak payah on. Yang ni temperature panas, room light okay, then onkan kipas, lampu tak payah on. Ni dua-dua problem, onkan kipas dan on. So now you have your truth table. This is what we call truth table. Now after this baru you masuk dia programming. Okay, so construct your circuit and then masuk dia programming and things like that. Alright, so this is how we do a project. Okay, so when you look at another example, this is another apa peranan controller. Alright, so that is the element that you want to put in your mechanical project, betul? Menjadikan project you automated, menjadi project you smart and things like that. You want to use a controller, definitely. Okay, kalau you nak purely mechanical, your mechanical project must be very very good lah. Tapi kalau you masukkan elemen electronics, you masukkan elemen controller, then walaupun mechanical you okay, elemen controller you akan menyebabkan project you di mata mechanical menjadi wow lah. Right? Okay, so that is something that you need to take advantage of. Okay, so you have a washing machine. This is a washing machine that is manual. That is a washing machine that is semi-auto atau automated. Right? Okay, so this washing machine, you masukkan baju, you sendiri yang kena agak, you have to estimate. Basically, if you are washing only two t-shirts, you don't have to put the water to the max, correct? Basuh dua baju je, then you letak air yang boleh tenggelamkan baju you, cukup lah, right? And then masukkan sabun, and then you sendiri agak-agak berapakah masa yang you perlukan untuk you basuh. So this is just a mechanical timer. This is just a mechanical timer atas ni. Okay, it's just a mechanical timer. You pusing, it's just turn on the motor, and then sampai dekat kosong balik dia akan cut off the power to the motor. Nothing special, nothing. Mostly maximum 15 minutes dekat situ. Okay, kalau you just dua lai baju, maybe 5 minutes or 7-8 minutes cukup. You yang putarkan dia lah. Okay, and then you yang kena keluarkan air balik, betul? Keluar drain air, and then you yang kena bilas, you have to rinse the clothes, and then you kena transfer ke sebelah, ke tempat spin, and then spin the clothes. Okay, this is a manual thing. There's no controller, there's no brain inside here. And you have to do it yourself, you have to estimate everything yourself. If you are using a automated punya washing machine sebelah, kalau you perasan, kalau you pernah basuh baju, right? You masukkan baju you, then dia akan pusing 3 kali. You tekan start, yes, dan then dia akan pusing 3 kali. Okay, so dia mula nak ratakan baju. Bawah itu ada weight sensor. Bawah washing machine ni akan ada weight sensor, alright? Sensor weight ni tadi will measure the weight of the clothes. And this information will be sent to the microcontroller, to the brain, to the controller, and then it will calculate the amount of water required. It will calculate the amount of time required for it to wash that weight of clothes. Okay, so semuanya automated. You just have to use to press start. So once it dah calculate the amount of water required, dia akan buka valve. Dia pakai mechanical valve, okay, electrical valve. Buka valve, air akan mula masuk. Air yang masuk tadi akan diukur oleh weight sensor yang sama. Okay, sampai pada weight yang dah dikalkulate tadi, dia akan tutup valve and then mula basuh. Okay, so tu yang kalau you perasan, kalau elektronik dia problem, kalau elektronik dia ada masalah, you akan nampak air tu masuk tak berhenti. Air masuk tak berhenti pasal weight sensor dah rosak atau board you dah rosak, dah problem. Okay, so those are the kind of things lah. So 10 years ago, you akan banyak isu lah, benda automated ni cepat rosak lah, apa semua kan. But nowadays, no lah. Nowadays is stable enough for everything to last at least 5 years, 7-8 years. Washing machine tu tak ada masalah. Okay, alright. So it has become more reliable. So if you look at the washing machine punya block diagram, you still have the same thing. You still have all your sensors. You have your weight sensor. You have your push button untuk user tekan start, betul? Output you ada motor, you ada valve, you ada display. That is all outputs, and then in the middle you have the controller. And if you look at the flow chart, it's a little bit daunting. It's a little bit atau tu nampak macam ni. But if you look at the flow chart, when you talk about microcontroller, okay, the most important thing that you have to decipher from here, apa yang you boleh dapatkan rumusan yang kat sini adalah everything works top down dan in a single line program. Dia bukan multitasking. Sambil dia baca berat baju, automatically dia boleh buka valve, tak ada. It's always sequence, in sequence, one after another. You tak boleh multitask dalam guna microcontroller. Alright? So first user tekan start. Adakah user tekan start atas sekali? Kalau user tekan start, next apa dia buat? Measure weight of the clothes. Right, lepas measure weight of the clothes, apa dia buat? Dia calculate the amount of water, wash time, instant. Lepas tu dia buka water valve, masukkan air, and then dia akan measure weight of the water, dah sampai ke tidak kepada weight yang ditetapkan. Kalau dah sampai, tutup valve, and then mula spin, mula basuh. Okay? Right, and then it goes on. But you can see it is not multitasking. It is just one way flow. Right, tak ada multitasking. Okay? So sebab tu, tapi zaman sekarang kalau you punya handphone, you boleh buka dua apps kan, atas bawah dan sebagainya kan. Dulu microcontroller tak boleh. There's only one task at one time. Okay? So this is a microcontroller. And as I said, it's dedicated to one task and run one specific program only. You mungkin pernah dengar Raspberry Pi, betul? You pernah dengar Raspberry Pi, you ada laptop apa semua. So those are two different things. Okay, Raspberry Pi is not a microcontroller. It's more of a computer. So kalau you tengok komputer ni, dia boleh buat multitask, betul? Boleh buat multitask. You boleh buka Word sambil buka Excel, sambil buka Facebook dan sebagainya, betul? Right? But it is big, processing power dia very huge, RAM dia pun tinggi, and things like that. Berbaloi tak you pakai laptop hanya untuk kontrol lampu dengan kipas dalam bilik? Berbaloi tak? It's not worth it, betul? Laptop sebiji dalam untuk kontrol you punya washing machine. So when you have one dedicated task, yang dedicated, yang buat benda repetitive, you just need to use a microcontroller. Cukup. You don't need to use a computer. So sometimes people is quite obsessed dalam dunia elektronik. Oh, I nak pakai Raspberry Pi, IoT I nak pakai Raspberry Pi, semua orang pakai Raspberry Pi, kan? Tapi projek dia nyala dan padamkan lampu. Alright, so sama juga macam you pergi masjid atau surau naik kereta Ferrari, sampai. Tapi kalau you naik motor pun sampai. Right? So buat apa rugi minyak dan sebagainya, betul? Things like that. Buat apa nak menyusahkan diri, lalu kat bumper je kena sengit pasal kereta lower sangat. Right? Those are the kind of thing that you as a future engineer have to decide on the correct tools to be used on your FYP project. Okay? Alright. So when you talk about electronics, we are going to talk about two signal, sama ada digital atau analog. Kalau saya suka analogi lampu ni kalau dikawal secara digital, you hanya boleh on dan off dia saja. Lampu ni kalau kawal secara digital, you boleh on dan off lampu dia saja. You tak boleh kawal brightness lampu ni. Kerana nak kawal brightness lampu ni, you kena kawal voltage yang masuk ke dalam lampu ni. Kalau 1 volt, 2 volt, 3 volt, makin tinggi voltage dia makin terang, makin rendah voltage dia makin gelap. Itu adalah dalam dunia analog. Analog dia ada continuous signal 0, 1, 2, 3, 4, 5 volt. Kalau digital sama ada 0 volt atau 5 volt. Dia tak ada tengah-tengah, 0 atau 5 volt. Kalau you tengok dari segi graf ni, yang kuning tu adalah digital. So it's either 0 or 5. But analog you ada 0, 1, 2, 3, 4, dia ada curve. Whereas kalau digital dia just a very solid square wave. Okay? So when we look at to control things atau measure things, you tahu tadi microcontroller akan terima input, betul? Terima input daripada sensor and then kawal output. Itu microcontroller. Terima input daripada sensor, proses apa yang dibaca and then kawal output, betul? Alright. So dua jenis signal yang dia boleh baca, dua jenis signal yang dia boleh kawal. So kalau you nak buat satu projek yang you nak kawal speed motor, tu maknanya speed motor you nak ubahkan dia daripada slow, laju dan sebagainya, kan? So maksudnya you kena guna analog output. Kalau you tak nak kawal speed motor, you just nak dia on atau off, then you boleh guna digital saja, cukup on atau off, bergantung pada projek lah. Sensor pun sama. Kalau you punya sensor, you kata I just perlukan dia sama ada dia terang atau gelap, 0 or 1, you tak perlukan dia punya vibration dia tu, fine, dia pakai digital sensor yang measure light. Kalau you nak measure actual lux dia tu berubah daripada tinggi ke rendah, dan you nak kawal output you pun, lampu tu akan berubah daripada tinggi ke rendah berdasarkan pada cahaya, then you kena guna analog input dan juga analog output. Alright? So that is the 4 skill yang you kena tahu lah. The 4 skill yang you kena tahu, which is when you talk about microcontroller, these are the 4 skills yang you kena tahu. And macam mana nak baca digital input, macam mana nak baca analog input, macam mana nak kawal digital output, macam mana nak kawal analog output. You dapat 4 ni, you should not be a problem. Okay? Dan sebenar-benarnya, although I cakap tadi copy and paste, budak selalu copy and paste and things like that, kan? Student selalu copy and paste tanpa ilmu. Okay, tanpa ilmu. So dia tengok gambar ni, okay, I nak macam gini juga sebiji, I tak nak beli yang lain, nanti projek I tak jadi pasal dia tak ada ilmu. I kena pakai coding ni, I ambil je coding ni, kan dia tak ada ilmu, dia tak ada upaya nak tukar ke, nak adaptkan dengan dia punya projek ke dan sebagainya. Dia nak pakai sebiji-sebiji. Alright. So but in reality, we never start programming from zero. It's always by looking at other people's program, copy and paste, and then know how to modify ataupun add on ataupun remove something from the project itself. Okay, maksudnya you takkan start from zero lah. You akan sentiasa ambil example daripada internet atau daripada Arduino itu sendiri, ada example, right? But then you must have the ability to understand what is going on in the program and change dan ubah. People never start from zero, okay, melainkan programmer sejati lah, right? Okay, so but we are not programmer sejati, betul? We are basically applying ataupun using the program. Okay, but for you to be able to understand the program, you mesti ada fundamental understanding of the language. You mesti tahulah, you tahu ni okay, ini adalah function, oh ini adalah baca sensor, oh ini adalah kawal output. You mesti tahu sedikit lah. Dan untuk you tahu sedikit, cukup 2 jam hari ni, cukup. Itu yang saya nak sampaikan lah. So I will not make you from zero to hero, you boleh buat programming from scratch, but at least 2 jam hari ni boleh memberikan you confident, untuk melihat program orang lain dan tak takut untuk copy dan buat perubahan. Itu je. Once you make it a habit, and once you have the lingo of the language, it should not be a problem for you to make adjustment to any program that you see. Okay, that is the most important lah. Okay, terutamanya masalah student, terutamanya dalam programming adalah program A ada bahagian sensor yang dia nak, program B ada bahagian output yang dia nak. So dia nak yang program A ni sikit, program B ni sikit. Tanpa ilmu asas, dia tak tahu macam mana nak copy ni dan buat yang baru. Itu masalah paling besar. Itu masalah yang paling besar yang student yang saya jumpa lah. Pasal dia langsung try to terjun masuk dalam programming tu, masuk dekat, kalau you belajar berenang ni, you masuk kat swimming pool yang paling dalam. You tak tahu berenang, tapi terjun tengok dekat kawasan swimming pool yang paling dalam. You lepas lah. You have to masuk dekat kawasan cetek dulu, belajar berenang dengan pelampung dulu, lepas tu baru masuk dekat kawasan ini. Okay, so that is my advice for you guys today. Okay, so I believe ada yang tak dapat kabel. Satu ini. I believe basically it is spread out. I hope that the Arduino is spread out. Not everyone will have the Arduino. Okay, but at least you are in close proximity to an Arduino lah. Okay, nevertheless, you can pass it around. If you already installed the Arduino, you can pass it around. Right, you boleh campur dekat komputer you, bagi kawan you pula upload. Should not be a problem. Okay, so you can pass it around. Kalau tak ada hands on ni, nanti saya khawatir you all akan boring ke apa kan, dia kan. So at least you have a feel of what is going on. So as I said earlier, you are much more fortunate if compared to the electronic student. Okay, I sebut you lebih fortunate daripada electronic student kerana mechanical student to learn electronics is much more easier with all the tools that is available. Right, all the tools available make it easier for you to use electronics. Arduino ni is not designed for electronics engineer, or it's not even designed for programmers. This Arduino is designed for art and design student. Arduino ni didesign untuk art and design student. Art and design sampai tu masa around 2004, 2005, dia nak dia punya art dia tu boleh bergerak, can imitate life and things like that, rather than just lukisan dia arca dia tu dia nak boleh bergerak dan sebagainya. So dia perlukan elemen control. So Arduino was designed for them. for people who don't have any prior knowledge of electronics or programming. So that is why it is an advantage for you, mechanical, untuk basically be involved atau gunakan element of Arduino into your project. Okay, so there's a lot of version of Arduinos. Yang I distribute tu is Arduino Uno. Ada macam-macam version juga yang ada kat YouTube. Ada yang Arduino Uno, ada yang Maker Uno, ada yang Arduino Dumilanov. Ada macam-macam version. Jadi tengok label dia tu, ada yang tulis Uno, ada yang tulis Dumilanov. Ada yang dia tulis Maker Uno, yang warna purple tu Maker Uno. Alright. Ada yang depan ni saya ada basically this is Nano. Okay, yang ada depan ni is Nano. This is Nano. Nano is a little bit smaller lah. Bila bandingkan Uno tu is very small lah. Okay. And this is a Node MCU. This is Arduino yang ada Wi-Fi. Okay. So this is directly boleh control through the internet. Right. So atasnya ada Wi-Fi tu lah. Boleh nampak tak? Wi-Fi. Lambang Wi-Fi tu. Tak nampak tapi nampak sikit lah lambang Wi-Fi tu. Right. Okay, so there are a lot of options and then there's a lot of built-in function in one Arduino. So we are not calling this a microcontroller. Kita tak panggil ni microcontroller, bagi kita panggil ni rapid prototyping board. This is a rapid prototyping board yang mana the main component atas dia adalah microcontroller. Nampak yang IC ni? IC hitam ni? This is your microcontroller. Okay, so kalau you cuma ada dia saja, kalau you cuma ada microcontroller ni saja, isu dia adalah this microcontroller saja yang bawah ni kan. Isu dia adalah you kena pasang pula electronic component untuk power dia, untuk dia communicate dengan USB computer laptop you, dengan dia punya pin dia tu you nak kena configure kan dan sebagainya. Okay, it's going to be very difficult. So apa yang dia buat adalah dia ambil IC bawah ni dan dimasukkan dalam satu rapid prototyping board. You tak payah fikir pasal power, you tak payah fikir pasal apa pun. Right? You terus boleh guna saja straight away. Right? Sebab tu dalam program electronics, pada peringkat awalnya ada lecturer yang tak setuju budak pakai Arduino ni. Dia tak boleh nampak ni atas ni. Pasal electronic you kena design your own PCB. Ni dah siap kan? Tapi you tak ada isu. You mechanical. Your focus is not on the electronics. Your focus should be on the mechanical. Right? So you don't have issue kalau you nak guna ni straight away. Right? Itu yang I kata you have it much more simpler than budaya electronics. Right? Okay, so there are a lot of version of the rapid prototyping board, macam-macam version. But what you have in your hand now is Arduino Uno. Is an Arduino Uno. Ada yang Uno, ada yang Dumilanov. Siapa yang ada Dumilanov angkat tangan? Siapa yang dapat Dumilanov angkat tangan? Dumilanov. Yo, Dumilanov ada dua kan? Itu Dumilanov kan? Bukan. Itu box tu, itu lain. Siapa dapat Dumilanov? Wanita kan? Bukan. Dumilanov. Tak, saya tak distribute yang kit ni. Kit ni saya tak distribute. Yang pakai yang kit ni. Yang pakai kit. Okay, saya cuma distribute yang ni je. Yang ni saja. Right? Okay. Alright. Tapi kalau you nak pakai yang tu, kalau you nak pakai kit, itu nano. Atas kit tu ada nano. Ni. Atas kit ni ada dua. Ni nano. Okay, ni nano. Ni Arduino nano. Okay. Dan ni Node MCU. Ni ada Wi-Fi. Ni Node MCU. Okay, ni nano and ni Node MCU. Okay. So Dan Nano ni, you ada Uno punya configuration dekat sini. Alright, you ada Uno punya configuration. Kalau you tengok ni dengan ni sama je Uno ni. Betul? Okay. You punya ilmu, kepakaran you boleh kena cover 4 benda. Digital input, digital output, analog input, analog output. Betul? 4 benda. Alright. So dekat atas board ni, you akan ada pin untuk masukkan maklumat 4 benda ni. Alright. So dekat sebelah okay, dekat sebelah sini adalah semua digital input output you. Sebelah sini. Sebab tu dia tulis tu digital 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sampai 13. So you ada 14, 0 sampai 13. Be careful lah, electronics always start with 0. So you bukan ada 13 pin. Termasuk 0, you ada 14 pin. You ada 14 pin bidirectional. Apa maksud saya dengan bidirectional? What do I mean by bidirectional? It can be an input or it can be an output. You yang decide. You decide pin mana yang akan jadi input, pin mana yang jadi output based on your project. Okay? Alright? So this is your digital input and digital output. Dah cover 2. Alright? So this is your analog input. Dah cover 3. Ini adalah input you. A0 sampai A5. Okay? Right. So kalau you perasan yang ni 3, 5, 6, 9, 10, 11 3, 5, 6, 9, 10, 11 ada lambang cacing. Ada lambang cacing, sine wave. Tadi kita cakap pasal sine wave ni apa? Analog. So 3, 5, 6, 9, 10, 11 boleh mengeluarkan analog output. Boleh mengeluarkan analog output. Okay? So maknanya kalau you nak kawal speed motor you, you bukan nak on off kan speed motor, you nak kawal speed motor you, then you kena guna pin sama ada 3, 5, 6, 9, 10 atau 11. You ada 6 pin analog output. Okay? Kalau you nak control speed tapi pakai pin nombor 1, tak ada label dia analog kan, dia tak boleh nak kawal speed motor. Dia hanya boleh on dan off motor you. Okay? Itu beza dia. So 4 skill tadi, digital input, digital output sebelah sini betul. Analog output sebelah sini juga 3, 5, 6, 9, 10, 11. Analog input sebelah sini. Okay? So semua dah ada 4. So bergantung projek you macam mana, you decide. Okay? Kalau you guna nano, you akan nampak benda yang sama juga. You still ada D13, D12, D11, D10 ada, sama je. Cuma dia dalam apa? Form factor yang lebih kecil, size yang lebih kecil. Okay? Okay. In addition to that, you ada power rail. Power rail you ada 5 volt, 3.3 volt. Alright, power rail katakan you nak ada temperature sensor, perlukan power. You ada light sensor, perlukan power. So you boleh tarik power dari sini untuk temperature sensor you ke, light sensor you ke dan sebagainya. Okay? You boleh tarik dari sini. So dalam electronics, apa-apa yang keluar power mesti patah balik ke ground. Dia mesti close loop lah. Dalam elektronik mesti close loop. Apa-apa yang keluar daripada power mesti masuk balik ke ground. Kalau tidak, you takkan ada close loop. Sebab tu orang kena pandang petik pasal apa? Orang kena electrocution pasal apa? Pasal dia yang provide pathway to ground. Always voltage akan try to find grounding. Okay? Dan kita akan tengoklah nanti bila kita buat circuit. Okay, so you ada USB atas sekali, USB port. USB port you bila you pasang je macam saya pasang ni, automatically you punya Arduino ada power lah. Automatically Arduino you ada power lah. Right? Dan USB ni juga membolehkan you hantar program you daripada laptop ke dalam Arduino. Alright? So arahan semua you type dalam laptop, and then you upload ke arahan you ke dalam microcontroller melalui USB. Dan juga apa-apa yang you baca daripada Arduino you, microcontroller you boleh hantar ke komputer. You baca suhu, you nak display suhu tu, you boleh hantar ke komputer. Right? Display atas komputer. Okay, so that is the usage of the USB. And then you ada built-in LED. You ada built-in LED. Ada built-in lampu. Okay, dan lampu built-in tu dikawal melalui pin 13. It will be controlled by pin 13. That is going to be the first program yang you akan buat. For you to test a microcontroller is working or not, untuk you test microcontroller ni berfungsi ke tidak, is the ability of the microcontroller untuk turn on dan offkan lampu. Itu test pertama yang you akan buat. Itu test pertama yang you akan buat. Boleh tak dia nyala dan padamkan lampu? Alright. So lampu yang dah memang built-in, tak payah nak cari lampu tempat lain, dah ada built-in dalam tu, pasang kat pin 13. So that is the first program yang you akan buat. Nak test this board is working, your software is working, and everything is functioning well. The first program yang you akan buat dalam dunia programming kita panggil hello world. The hello world of a microcontroller. Boleh tak you padam dan nyalakan lampu? Itu dia. So you tak payah nak cari. Kalau tidak, you boleh cari LED macam ni. Nak kena cari LED macam ni, pasang sikit, tak payah. Atas sudah ada built-in LED dekat pin 13. So you are going to do your first program, kawal digital output pin 13. Okay? Right? Okay, so I want to straight away go into the program. I tak nak pening-peningkan you all dengan all the electronics for the time being. I just want to use the electronics. Want you to experience first. Jom kita buka Arduino. Atau siapa yang dah ada Arduino boleh buka Arduino. The software. I dah bagi you the hardware. Now we will look at the software. Okay? So kalau you dah install Arduino, you akan ada shortcut. You will get the shortcut in your desktop. Automatically you akan ada shortcut in your desktop. Okay? So the shortcut, the logo is going to be infinity logo plus minus. Ada infinity logo plus minus. So you can just double click. So far so good. My food poisoning is not acting up. Okay, right. I still have 2 hours to go. Okay. Okay, you will have something like this. I besarkan I punya font. Okay. I besarkan font. Okay, I tengahkan. You don't have to. If you have any question, straight away you can ask. If you have any questions, straight away you can ask. Nampak tak? Yang belakang nampak tak? Okay. Alright, if you look here, this is when you open up Arduino, you will have this program. Betul? You ada this program. Alright. So if you can look at here, the only difference between your program and mine is that I dah ada nombor kat tepi ni. I don't think so you ada nombor kat tepi ni. Okay? So if I were to delete everything, okay, this is what we call line numbering. Ni I tekan enter. I tekan enter. So this is what line numbering is. So dalam programming, line numbering is quite important because every single, this is what we call an IDE, Integrated Developers Environment. Integrated Developers Environment. Program sebenarnya you boleh buat anywhere in a text editor. You boleh buat kat Notepad, you boleh buat kat WordPad, you boleh buat dekat Microsoft Word pun. And then you boleh kena compilekan dia, convertkan dia pada machine language. But bila you guna IDE, dia ada built-in debugger. Problem software dia akan panggil bug. Kalau you ada bug dalam you punya apps ke apa, dia akan act up. Betul? Dia akan ada problem. So every single IDE akan ada debugger. So kalau you buat masalah, kalau you buat problem, error yang akan keluar, dia akan keluar sekali dengan debugger dia punya solution. Line 10, this is the issue. So you kena cari line 10 tu kat mana. Kalau you tak ada line numbering, kat mana you nak cari line 10? Ataupun selalu program you takkan sampai 10 je. Program you kadang beratus-ratus line. Katakan program you dekat line 345. Macam you nak scroll down cari 345, line yang ke 345, betul? Payahan. So normally people akan onkan dia punya apa? Line numbering. Okay. So how do you want to turn on your line numbering? Go to File, go to Preferences. Okay, go to Preferences. So kat sini ada Preferences. You boleh set font kalau you nak. You boleh set font kalau you nak. Tapi yang paling penting sekali kat sini ada display line number, betul? Ada display line number, betul? Yang bawah ni. You boleh turn on and then press OK, and now you have your line numbers lah. Right? So normally student saya yang masuk lewat dalam kuliah, dia masuk lewat dalam kuliah, dia terlepas benda ni, dia tulis ni satu. Satu ni should be automatic, 1, 2, 3 tu should be automatic. When you press enter, dia akan automatic. Right? So make sure everything is clear. Make sure everything is clear. Delete semua. I want to start from zero. For your understanding of the fundamental, I want to start from zero. Kalau you dah, tadi kan dah ada coding sikit ke, just delete everything and zero kan macam saya ni. Okay. So what I want to stress first is this: programming hierarchy. Okay. So the lowest instruction, the simplest form dalam coding yang you ada is instruction. Turn on, turn off, the one line instruction. Okay. But when you kumpulkan a couple of instruction, when you group a couple of instruction together, you will create a function. Alright? So you groupkan kawal motor kanan, kawal motor kiri, you jadikan dia function untuk control robot. Katakan. Alright? Okay? So then you akan ada function. Kalau you group together instruction and function, you akan create a library. Okay? So Arduino, dia akan wajib ada dua function, walaupun dalam dia tak ada instruction. Okay? Tadi saya kata apa? The simplest form in coding is instruction. When you group a couple of instruction together, you will create a function. Right? So Arduino wajib ada dua function, walaupun dalam dia kosong, walaupun dalam dia tak ada instruction, wajib ada dua function. Dan function ni nama dia setup dengan void loop, dengan setup dengan loop, dua. Apa dia dan bagaimana dia berfungsi, mari kita tengok. Alright. So instruction dia ada dia punya cara, function dia ada dia punya cara untuk kita create dia. Right? Start off with void. Kecil sangat ke? Nak besarkan lagi? Okay. In coding, bila you buat coding, it's always good to have a bird's eye view of your code. It's always good to have a bird's eye view of your code. You mesti nak nampak you punya code secara keseluruhan. That is why orang akan buat pakai font yang kecil, so dia nampak the whole thing. Alright? Easier like that. Tapi this is a lecture, right? Kan you tak nampak belakang, so kalau you tak perlu besarkan, jangan besarkan. Because you want to see the beginning of the function and the end of the function in one screen. Betul? You tak nak tengok beginning function, lepas tu end itu dekat bawah. You mesti nak nampak semua supaya you nampak flow dia. Right? Okay? So but for the purpose of lecture, I pakai font besar lah. Right? So that is another tip for you guys and girls. Alright, so function. This is the format. This is the format of a function. I cakap kena ada dua function tadi kan? Setup dengan loop. So the first function is setup. Nama dia setup. Okay? So mesti ada void depan tu. Nama function, buka dan tutup bracket. Buka dan tutup bracket. Okay? Okay, so kat sini there are two annoying thing about C programming. This is C programming, the mother of all engineering programming language. Alright? So mechanical pun I think you ada kot belajar C. Elective, but it's the most important programming language in engineering. Right? Because semua berdasarkan pada C. Java apa semua more or less C. You belajar Python pun more or less the same concept applies. Alright? There's a little bit difference here and there. Alright. Okay, so void setup, ada two things that is annoying about C. Ada dua benda yang paling annoying about C. Number one, case sensitive. Case sensitive. You tengok kalau I ubah V ni jadi V besar, dia akan jadi warna hitam. Alright? So dia case sensitive. Maknanya dia tak kenal ni sebagai the template that you should use. You will have an error kalau macam ni. So be very careful huruf besar dan huruf kecil. Right? Be very careful huruf besar dan huruf kecil. Okay? And another thing that is annoying about C is the syntax. This is not available in Python. Python tak ada isu tentang syntax, but C ada isu tentang syntax. Open bracket, tutup bracket, lepas tu ini bracket yang atas tu kan, kalau bermulanya function adalah open curly bracket, dan bila you tekan enter je, perasan bila you tekan enter je, automatically dia akan tutup curly bracket you. Automatically dia akan tutup. Okay? Dalam ni lah yang you letak you punya instruction. Dalam ni ada instruction. All here is instruction. For example lah kan, here instruction. Okay? Walaupun tak ada instruction void setup ni, walaupun tak ada instruction you letak dalam ni, still it is compulsory to be there. Still it is compulsory to be there. Okay? Okay? So the curly bracket menanda bukanya bermulanya function, penutup curly bracket itu menandakan berakhirnya function. So that dia punya pagar dia. So tadi bracket biasa betul, void setup bracket biasa, lepas tu curly bracket. So that is another annoying thing about C. Be careful of the syntax. Nampak dari jauh macam sama je bracket semua kan. Be very careful of the syntax. Alright? Okay. So another function that is compulsory to be there is void loop. Alright? So sama juga kena ada void. Nama saja berbeza, loop. Nama saja berbeza. Masih lagi ada buka tutup bracket, masih lagi dimulakan dengan curly bracket, tekan enter dia akan tutup. Okay, these two function is compulsory to be there inside Arduino IDE. Wajib. So bila you buka program lain, you tengok, oh ni buat setup dia, ni buat loop ni. You tahu dah. Right? Bukan jadi pelik tengok apa setup ni kan. Right? Okay. What is the difference between void setup and void loop? Void setup is dia run hanya sekali saja. Dia run hanya sekali saja. Let's say jangan copy ni jangan copy ni. Let's say you on LED for example, and then you off LED. You letak dalam void setup. This is saja letak dalam void setup. So void loop kosong tak ada apa-apa dalam void loop. Bila you run, dia akan nyala LED, padam, kemudian dia akan masuk dalam void loop. Pasal void loop kosong tak ada apa-apa kan, then nothing happens. So you akan hanya nampak LED you nyala, padam, lepas tu dah tak ada apa-apa berlaku. Tapi kalau ada hal yang sama, the same instruction, you letak dalam void loop, what it will do is that dia akan masuk setup kosong tak ada apa, so you see nothing happening. And then dia masuk dalam void loop, dia akan on, off, loop balik, on, off, loop balik, on, off, loop balik, until you turn off the microcontroller. So that is the difference between void setup and void loop. Whatever you put in void setup will run only once. Whatever you put in void loop will run forever. So depend on your project, you nak buat macam mana. Projek ni nak jalan sekali ke atau nak jalan berulang kali? Depends. Okay? Alright? Ada soalan tentang ni? Clear Sebab itu kalau you buka file, you buka new, kalau you buka file, you buka new, ini yang you nampak ada, betul? You nampak, oh dia dah bagi you buat setup dan dia dah bagi you void loop, betul? Wajib ada. So dia dah bagi you siap-siap, tak payah nak buat sendiri. Tapi apa pula benda ni? This is comment. This is comment. Maknanya apa-apa selepas double slash will be ignored by the program. This is just notes yang you nak letak dalam tu. Okay. So kalau you buat notes ni, you will have the same thing. While loop dengan void setup. Okay. Right. Clear eh? Tapi I tak suka cara dia susun curly bracket. Dia letak curly bracket tu kat atas kan. Letak curly bracket ni kat sini kan. Kadang-kadang dia kita tak nampak kadang-kadang dan sebagainya. Right? And another thing, kalau you letak you punya cursor dekat tutup curly bracket ni, dia akan box up kan yang buka dia. Dia akan beritahu, oh ni tutup, oh ni buka, dia beritahu. Kalau you letak dekat buka bawah ni, dia akan beritahu ni penutup dia. Right, so basically it assists you lah. So that is IDE, yeah. Alright. Okay, jom nyalakan lampu. Okay, so Arduino Uno you ada pin 13, correct? Pin 13 dia akan nyalakan lampu ni. Lampu atas ni yang sekarang ni tengah berkelip. Lampu you semua tengah berkelip, betul? Satu saat on, satu saat off, betul? Lampu you semua tengah berkelip. Pasal saya yang coding dengan dia semalam. Setiap satu tu saya masukkan coding, berkelip satu saat on, berkelip satu saat off. Kecuali nano saya tak tahu. Okay. Yang nano pun boleh, siapa ambil nano tadi boleh. Bukan tu, nano. Bukan guna nano yang ni. Okay, you boleh sambungkan kabel kalau you nak. Alright. So pin mana? 13. Okay, skill yang pertama, digital output. I nak cover 4 skill dia ini. Digital input, digital output, analog input, analog output. Okay, so kita try dalam masa 4 jam ni. Termasuk IoT saya akan tunjukkan sikit. It's quite ambitious. Okay, tapi okay insyaAllah. Digital output, the first skill, digital output. Pin mana? 13 saya nak pakai. Pasal atas ni dah memang ada LED. Alright, okay. So dekat atas nano pun dah ada LED. Ada LED atas nano ni. Alright. So first kali kita dah beritahu tadi, every single digital pin tu adalah bidirectional. Every single digital pin tu bidirectional. 13 pun sama juga, bidirectional. Boleh jadi input atau boleh jadi output. Okay. So kita kena beritahu Arduino, I nak pin mana I nak pakai, I nak jadikan dia input ke I jadikan dia output. Nak nyalakan lampu betul? Nak nyalakan lampu dia kena jadi apa? Output ke input? Kalau lampu ni output ke input? Output. Output Dia jangan kuatir. Saya ada student master elektronik pun salah jawab. Okay? Pasal bila konsep block diagram itu penting. Lampu tadi sebelah mana? Sensor sebelah sini, betul? Sensor adalah input, actuators output ni semua, lampu, motor, tu semua adalah output devices. Display, right? Okay. So kita nak kawal lampu, we want the pin to be an output. Alright. So you have to basically use the instruction called pin mode, M capital. Pin mode M capital. Alright, open bracket, and we have to give it two information. Pin mana, input ke output. At the end of the day, it's all about common sense. At the end of the day, it's common sense. Dia mesti nak tahu pin mana yang nak pakai, input ke output. Okay. So pin mode M capital. Kalau M you tak capital, dia akan warna hitam. Then you have a problem. Okay. Pastikan MU capital dan you punya coding tu akan warna orangey. Right, then you are on the right track. Right. So buka bracket, normal bracket Okay, give it two information. Pin 13, you want to use pin 13, comma, SN, output. Okay, pin 13, SN output. Okay, alright. Every single instruction ends with a semicolon. Every single instruction ends with a semicolon. Alright, remember that. Function tadi ada semicolon tak? Function ni? Tak ada. Every single instruction ends with a semicolon. Alright? Okay. So now Mungkin you akan tanyakan, saya tanya sendiri dan saya jawab sendiri, kenapa letakkan buat setup pin mode? Okay, because you only need to tell it once. 13 you are an output, finish. You don't want to tell it over and over again. 13 is output, 13 is output, right? Okay, just tell it once, and that is the role of the setup. You want to set up only once, right? So pin 13 is an output, right? Finish. Okay. So now I will want to control my pin in the while loop because I nak tengok dia continuously on, off, betul? Kalau I letak dalam setup, dia hanya on dan off sekali saja and then finish. So I want to test it and I want to test it continuously, so I put it inside while loop. Okay. So your first instruction to control a digital output is going to be digital write. Again, you tengok dia punya formatting W is capital. Right? So in all the madness of C, dalam gila-gila C ni, dia still ada dia punya format and dia punya template. Right? So every single word that is combined together, the second will start with a capital letter. Right? So digital write W capital, pin mode M capital. So you will get the hang of it. Along the way you will get the hang of it. Right? So digital write W capital, right, must be orange in color. Right? So again, two information. The bracket indicate that you have to put information inside it. Right? So two information. Which pin? 13. You want first I nak nyalakan dia lah. In the initial state dia akan off, betul? Initial state dia akan off. So I nak nyalakan dia, so I will basically make it high. And every instruction akan ends with a semicolon. Okay? Alright, okay, let's say kita nak turn dia on. So kalau I run this program, this LED akan turn on sahaja. Adakah dia akan turn off? Tak. Always remember, coding is always lurus bendul. Lurus bendul maksudnya dia akan hanya buat apa yang you suruh dia buat. It's a very straightforward guy. Alright? Kalau you tak suruh dia padam, dia takkan padam. Remember that. Right? So sometimes in our mind, kenapa dia tak padam Kalau you tengok pada program you, memang you tak suruh dia padam, dia takkan padam. Right? Okay? So katakan kita nyalakan dia saja, fine. Kita akan tengok dia different sikit dari sini. Right? So let's say we want to upload this program. Now the program is in our laptop, yes. We want to then send the program here. Right? So what you need to do is go to tools. Siapa yang ada Arduino lah. Go to tools. So dekat board, go to Arduino AVR board. Now select your board. This you have to be very careful. Select your board. Select your board. My board is an Uno. My board is an Uno. Okay. So I will select Uno. Kalau your board is a Dumilanov, select yang Dumilanov. Kalau your board is a Nano, select yang Nano. Okay. Depends on your board. Right. Ada tak yang ambil yang board panjang tu? ADK, Mega. Siapa ambil yang panjang? Okay. You punya board is Mega ADK. Yang ni dia tulis tu Mega ADK ke? Guna yang tu. Okay, remember So I do not want you to go out from this workshop, from this talk today. Oh, Uno, beli apa-apa pun tekan Uno juga. Sampai sudah tak boleh upload. Okay. Alright. So next, I pilih Uno, I pilih Uno. Yang mana Dumilano, pilih Dumilano Right? Okay. So I dah pilih Uno. The next thing, I want to basically choose the port. Kalau I beli yang original, this is an original Arduino, dia akan tulis dekat situ Arduino Uno, macam kat depan. Dia tulis tu Arduino Uno. This is an original board. Dia tulis tu Arduino Uno. Siapa yang dia tak tulis apa-apa kat situ? Katakan? Siapa yang dia tak tulis apa-apa? Dia just tulis COM je. COM 5, COM 6, dia just tulis tu je. You dah sambung belum you punya kabel? Siapa yang dia tak tulis Arduino Uno macam saya, dia tulis COM 3 saja. Kan? Tak ada, semua keluar Arduino Uno. Seorang je, 2. Saya rasa banyak yang saya supply clone ni. Ada 3, ada 5, 6 clone. Lain semua keluar Arduino Uno. 2 orang yang dapat clone. Okay, this Arduino is an original Arduino. Yang mana yang dapat clone tadi yang katakan? Tunjukkan Arduino je. Tu Arduino clone, Arduino penipu. Harga ni RM15 boleh dapat. Ini Arduino RM100. So dia clone Arduino, dia original Arduino. Depend. I akan beli compatible Arduino. Ada tak yang warna hitam? Katakan Arduino warna hitam, dia punya lining ni warna kuning. Warna hitam tapi dia punya pin ni warna kuning. Hitam kuning. Kuning So tu kita panggil compatible. Right, compatible dia akan ada logo dia sendiri, KS Studio dan sebagainya. Right, so be very careful bila you pergi beli Arduino. Contoh lagi contoh because this is part of puzzle untuk you beli kan. Okay, kita masuk Shopee. Allah, tadi internet. Tak apalah, nanti I tunjuk But there are 3 types of Arduino: original, compatible dengan clone. Right? So clone ni yang bahaya because dia punya form factor ni semua, dia punya logo ni semua sama macam Arduino yang original. Bila dia sama dengan original, dia tak boleh bezakan antara clone dengan original. Dan dia tak ada accountability. Okay, dia tak ada responsibility terhadap produk dia. Then you will see a product that is, kalau you beli 10, 7 akan rosak. 3 je yang nasib you akan baik, 3 akan rosak, 7 je yang akan you nasib baik beli yang tak rosak. Alright, so depends. You can get Arduino as cheap as RM20. Alright, as cheap as RM20. Kalau you tak ada kompot, you tak ada label macam saya ni, Arduino, kompot, tak ada tulis Arduino Uno, dan you ada 3-4 COM 3, COM 4, COM 5 katakan. Alright, you tak sure Arduino you sama dekat COM mana. Alright, macam saya ada 1 je kan, so definitely yang ni lah. Tapi kalau you timbul COM 3, COM 5, COM 6, you tak tahu COM yang mana, you can go and search, go to your device manager. Go to your device manager. So dekat device manager you, pergi ke ports, COM dan LPT. Pergi ke COM, ports dan LPT. Dekat sini dia akan tulis itu COM mana yang bersambung. So dia tak tulis Arduino Uno, dia akan tulis Silicon Lab something. Alright, so that is another way to it. Tapi masih upload, kalau tak boleh you angkat tangan, then I'll come to your place. Alright, and then bila you dah tengok COM mana dia pasang, go back to your tools, go back to your port, pastikan you dah tick the COM port. Pastikan you tick the COM port. Ada tick kat situ. Alright, kalau you dah done, you have 2 options now. Whether you want to compile, verify. This button tick ni adalah verify. Ni verify saja. You tak ada hardware, you tak ada Arduino, you nak verify saja, you just boleh tekan sini, dia akan verify. Dia minta you save. Kalau you nak save, you save. Let's say this is test LED. Test LED poly. Let's say save. Alright, dia akan compile, verify without uploading. Dia tak upload. Alright, katakan you tak ada bot, dia tak ada bot, you just nak tengok ada error tak ada error. So you just compile without uploading. So dia akan try tu ni lah. Okay, done compiling, done. Tapi dia tak upload dia tak upload. Kalau you ada bot, you don't need to verify, you just straight away upload. You don't need to verify, you just straight away upload. Because when you upload, dia akan verify dulu and then upload. So you don't have to do twice. Okay. So compile, uploading. So dia dah done uploading. So I will have my LED turn on without turning off. Dia tak blink lah. Dia tak blink lah. Okay. Okay, dia tak blink. Dia nyala je, dia tak blink. Dia nyala saja dan dia tak blink. Kita suruh nyala je kan? Kita suruh dia padam. Right? So dia nyala je. Any issues? I'm changing my Arduino to Nano over here. Right? So let me just pin this. Okay, so I'm changing my Arduino to Nano. So this means that I have to use tools, Arduino, AVR. I'm changing it to Nano. And tools, processor. I have to change it to old bootloader. Kalau you guna Nano, you have to change it to old bootloader. And the port has also changed to COM24. Upload. So my LED over here will turn on. Tu warna merah will turn on. Okay? Alright? The LED now turn on. Okay, so we want to make it blink. We want to make it blink. Right? So I cannot simply do something like this. I cannot simply do something like this. Digital right, pin 13, low, because it doesn't make sense. Okay, so what do you expect will happen? You boleh teka tak apa yang berlaku ni? Satu, adakah you nampak LED tu padam saja? Dua, adakah you akan nampak LED tu nyala saja? Tiga, adakah you akan nampak dia blink? Nyala padam, nyala padam, nyala padam. What do you expect will happen? Boleh teka? A, B, C. Nyala saja, padam saja, blink. Blink. You rasa dia akan blink? Kita tengok, kita boleh upload kan? Perhatikan lampu merah ni Compiling, uploading, done. Apa jadi? Kita nampak dia nyala saja. Right? So dia akan void loop, nyala, padam, nyala, padam, nyala, padam. So dia padam tu hanya dalam 18 microsecond. Dia padam tu 18 microsecond. Nyala, padam 18 microsecond, nyala balik 18 microsecond, padam, nyala balik, padam. Nampak tak? Alright, okay. So kalau I masukkan, apa yang I kena buat is I kena masukkan delay. So what delay does is, let's say delay 1000 So what delay does is, dia akan sit there without doing anything. So high, 13 high, wait for 1 second. Dalam delay punya instruction tu 1000 to 1000 millisecond. It is in millisecond. Right, so meaning that kalau you nak dia 2 second, dia 2000. Kalau you nak half a second, if you want it to be half a second, then kena 500, 0.5. Right, so and then the same thing, I nak tengok dia padam juga for similar delay. So what is happening here now is, Nyala 0.5 saat, and then padam 0.5 saat, void loop. Nyala 0.5, padam 0.5, void loop. Nyala 0.5, padam 0.5, void loop. Okay? So bila I upload, I will have my blinking effect lah. Okay? So I will have my blinking effect lah. So digital output as simple as that. Digital output is as simple as that. The same goes to kalau you nak on off kan motor. As simple as that. Digital write, done. Right? On off. Okay? You nak on off dia based on certain sensors, then a little bit different lah. Okay? Katakan I nak lajukan 0.1 saat or 100 is 0.1 saat, then I upload. So you can play around with the delay. Okay? Okay, so alright. If your delay is too small, the frequency of blinking is too fast, you nampak macam dia nyala je. Because, true? Right, so that is something. Kalau you letak delay 1 millisecond, you akan nampak macam dia nyala je. Dia still blinking, but at a very fast frequency rate. Okay? But every single time dia akan pimot lah. Pimot. You can never in program berubah pula P13 input, lepas tu along the way jadi output pula. Because nanti dia conflict pin kan. You know, do that. Okay? You need to do. You have to construct the LED, right? So like this, okay? LEDs, and then you have to then find the pin, construct it, and things like that, right? So we don't have the time for that for today. And more or less you are mechanical, right? So you are going to use all these modules, by the way, yeah? You takkan buat sikit, you just pakai modul-modul macam gini kan. So that's why I'm showing you modules based. And modules can save you a lot of time as well. Right? So if you look at your traffic light, you have ground, definitely. You mesti ada ground, betul? You have ground, and then you have RYB, red, yellow and green. Red, yellow and green. So what I'm suggesting is, right next to pin 13, right next to it is ground, correct? Next to pin 13 is ground, here, correct? Next to pin 13 is ground, betul? Uno kan? Siapa yang pakai board kit tadi tu, you look at the Uno punya footprint, right? So you have the ground. So what I'm proposing is something like this. Pin 13 pergi ke merah, pin 12 pergi ke yellow, pin 11 pergi ke green. Ini kita nak main lampu isyarat. Okay? Boleh? You ada jumper tu kan? Jumper tu female to male, betul? Jumper tu female to male, betul?
definitely lah female tu masuk kat traffic light, betul? Yang male tu pergi ke ball kuno. Okay, sila pasang. Siapa yang dah siap pasang? Common sense, apa you rasa kena tambah dekat coding? Tadi kita cuma control pin 13, we only control pin 13 prior to this. Now we are adding pin 12, and then we are adding pin 11. Correct? Okay, so if you can copy paste, use your copy pasting skill. You kena ada pin mode untuk 12, you kena ada pin mode untuk 11. Common sense, betul? Right? And then blink 13 you dah ada, blink high low 13 you dah ada, betul? You must have the same blink for the red, for the yellow, and also the same blink for the green as well. It's just a matter of copy paste and then change the pin number. That is my hint to you. Right? Okay? Okay? Dah senang je kan? Ini very straightforward. So ground, so once you pasang 13, your 13 akan double click lah, definitely, because this is program lama. This is the old program. The old program is 13 berklik, betul? Right? So without you uploading anything, 13 akan follow the previous program. Right? So what you need to do is just pin mode 13. Now you copy. Tak payah nak type pun, copy paste. Dia ada 3 kan, and copy and paste. So you ada 13, 12 dan juga 11. Okay, alright. And then now you have, this is 13, correct? 13. So you copy everything, and I always have a gap macam gini, so that I can clearly see yang ni 13 gap, yang ni 12. This is just for easier for us to look at. Macam karangan ada perenggan, so you nampak jelas ini 13, ini 12, betul? Right? And then yang ni 11. Okay, 11. Right? 13, 12 dan 11. Okay, so now you can run. I dah tukar board 2 Milano. So now I have my traffic light lah. Laju lah traffic light ni, delay 100 kan. going to be a very fast traffic light. The delay is only 100. Okay? Alright? So that is why I like the text to be small, so that I can see the whole thing, right? Now my text is quite big, so I cannot see the whole thing, right? Okay, this is not the 199 traffic light dekat Shah Alam, This is quite fast traffic light. Okay, done? Kenapa merah hanya nyala? Okay? Alright. Done? Okay, done, So, that is very straightforward. So now I want to look into, we have another 50 minutes, so I'm going to straight look into analog output. So this is digital output, on off, on off, on off. So I want to look at analog output. So analog output, you only have pin 3, 5, 6, 9, 10 and 11. 3, 5, 6, 9, 10 and 11. So I want you to shift your LED. Now you use what? The 13, 12, 11, correct? The only PWM pin here is pin 11. The only PWM pin here is pin 11. I want you to shift everything to 3, 5, 6, 9, 10, 11. So 9, 10, 11. Meaning that shift your red, green, blue to 9, 10, 11. From 13, 12, 11, shift it to 9, 10, 11. 11, 10, 9. Okay, shift it to 11, 10 and 9. So your sequence is going to be 11 is going to be red lah kan? 11 red, yellow is 10, 9 is green, correct? Kita shiftkan dia ke pin PWM. Shift to 9, 10, 11. So when you shift, only the red will turn on lah. Pasal red tu 9 kan, betul? So 9 tu turn on lah. That is the whole program. So now we want to look at this 9, pin 9 red ni. We want to control the brightness of this rather than only on and off. We want to control the brightness of this rather than only on and off. Okay, alright? So this is much more usable in our mechanical things lah. You takkan nak on off kan kipas tu macam tu atau motor tu macam tu je. You mesti nak boleh kawal speed. It's very important. Right? So now your red connected to pin 9. Agree? Your red connected to pin 9. I dah shiftkan 10 will be yellow and 9 will be green. 11, 10 kan? Yes, 9 will be green, betul? I shiftkan dia macam tu kan? Right? I suka merah, pasal merah tu terang. Hijau tak berapa terang sangat. Right? Hijau dia tak berapa cantik. Okay? For me, the merah is the brightest one. So that is we want to control the brightness. Alright? So, very straightforward. Okay, analog output, a little bit of analog output. What is analog output is all about? So if you want to control the brightness, you have to use the analog output. Analog output has a range of voltage. So how does it work? How does it work? It is still using a digital pin. Dia masih gunakan pin digital, but the on and off will be controlled by the width of the signal itself. Okay? So now the rule for this is that kita akan kontrolkan pin ni dengan frekuensi yang quite high, frekuensi yang around 1K and above, right? So kalau lampu tu you tengok on off, delay dia very slow, you akan nampak dia on off dan you nampak lah dia blinking. But when you reduce the delay, you increasekan frekuensi, dia akan blink dengan lebih laju sampai tahap you tak nampak dia blink pun. Tapi sebenarnya lampu ni pun, lampu fluorescent lamp ni is blinking. It's at a certain frequency. TV you pun ada certain frequency. Dia punya frequency rate dia tu. You beli TV kan, tulis tu kan, berapa frequency rate dia. So it is still blinking, but it's blinking at a very fast rate. The same concept applies here. So when you turn on and off at a very fast rate, the output that you get is the average of the width of your on time. Kalau you on kan dia 50% of the time, your output tu akan average kan 50% of your supply. Supply you 5 volt, you on off the 50% on, 50% off, you akan dapat 2.5, half. Kalau you on kan dia 10% saja, dia akan dapat 0.5. 10% of the 5 volts. Kalau you on kan dia 90% of the 5 volts, meaning that 4.5. This is how you varykan voltage ni. Yang sebelumnya you hanya ada 0 atau 5. Tapi sekarang playing around with the width of your pulse and basically repeating it at a very fast rate, high frequency, you can get a very output voltage. You boleh dapat output voltage yang you boleh ubah dan kawal. rather than only 0 or 5. You ada 0 to 5. Beza You boleh ada kosong hingga 5. Sebelum ni you cuma ada kosong atau 5. Alright? So two different or and and. Alright? Okay? So now kalau you punya analog output tu cuma 1 bit, kalau analog output you cuma 1 bit, dia akan dapat balik apa yang kita dapat sebelum ni. You cuma ada dua kemungkinan je. 1 bit maknanya 2 kuasa 1. 1 bit maksudnya 2 kuasa 1. 2 1 berapa kemungkinan? 2. So you cuma ada kosong atau 1 untuk mewakili output voltage you. So dia akan basically maximum voltage you adalah 5, maximum digital you adalah 1. So you akan dapat times 5. Kalau you masukkan kosong times 5 dapat kosong, you masukkan 1 times 5 dapat 5. You akan dapat sama macam you dapat sebelum ni, digital bit. Dia akan jadi interesting kalau you pakai 2 bit. Kalau you pakai 2 bit, sekarang you ada 4 kemungkinan untuk mewakili output voltage you. You ada 00, 01, 10, 11. Right? So maximum you adalah digital 3. Betul? Maximum voltage you adalah 5. Ni kekal 5. So sekarang formula you adalah 5 bahagi 3. So sekarang you dah ada 4 perwakilan. Kalau you masukkan kosong, dia akan keluar kosong. Kalau you masukkan 1 darab 5 bahagi 3, you akan dapat 1.67. Kalau you masukkan 2 darab 1.67, you akan dapat 3.3. Kalau you masukkan 3 darab 5 bahagi 3, you akan dapat 5. So sekarang, daripada hanya 2 brightness sebelum ni, kosong atau 1, you dah ada 4 brightness. Kalau you sambungkan motor, you ada 4 different speed of motor. Faham? So that is how it works. Arduino ada 8 bit PWM. So 2 kuasa 8, you ada 256 levels of voltage yang you boleh kawal daripada hanya 2. So daripada kosong ke berapa? 255. 256 kemungkinan daripada kosong hingga 255. Okay, so ini bermakna kalau you boleh masukkan digital you berapa tadi? Daripada kosong hingga 255, apa nilai yang you masukkan daripada kosong hingga 255 akan darab dengan 0.01956, that will be your output. Okay, so kalau katakan you nak 2.5, you nak separuh 2.5. So berapa input yang kita masukkan? Around 128, 127, half of 255. Alright? So now you can very fine-tunekan speed motor you. You boleh fine-tune speed motor you. So you bayangkan contoh. You bayangkan you nak kawal robot. You bayangkan you nak kawal robot. Okay? You kawal robot ni pakai differential drive. Differential drive maksudnya, differential drive, kalau you nak jalan tegak, motor kanan dengan kiri sama speed. Kalau you nak jalan belok sini, kalau you nak belok ke sini, speed yang sebelah sini kena lebih laju daripada speed yang sebelah sini. Betul? Dia pusing sini. Kalau nak pusing sini, speed yang sini kena lebih laju daripada sini. Betul? Dia akan pusing sini. Right? Clockwise jalan depan, anti-clockwise jalan belakang. Okay. Kalau you cuma ada on dan off, bila robot nak pergi curve, nak handle curve yang 90 degrees punya curve tu, KLI Sepang punya curve tu, kan? Kalau you tak ada ability nak kawal 256 different speed, macam ni you nak handle that corner tu dengan baik, right? In terms of robot punya control lah. So the higher the value of probability that you can get, the better your performance of your motor speed dan sebagainya lah. Right? So daripada hanya lampu tu on and off, sekarang lampu you boleh kawal brightness. Okay, so your LED, the maximum brightness is around 1 volt. maximum brightness LED ni around 1 volt. Lepas 1 volt dia dah tepu dia punya brightness sampai 5 volt. Okay, so if you look at this, around 100 you dah dapat 2.4 volt. Around 100 you dapat 2.4 volt. So kalau I nak cap it at 1 volt, I will play around 50. Okay, so as to just illustrate my point, formula dia tadi apa? 0.0156 kan? Kalau nak my output is 1 volt, I need to divide by, kalau sini pergi ke sana, digital pergi ke analog, dia darab. Kalau you nak dapat daripada analog balik ke digital, you kena bahagi, dia transpose lah kan. Alright, so I nak analog I 1 volt, pasal I tahu maksimum LED ni cuma 1 volt. I nak cap dia nak 1 volt. So I masukkan dalam formula 1 bagi dengan I punya formula 0.01956. So my output, my digital, I can cap dia dekat around 50. Alright, so that dia tak, lepas tu dia dah tepu lampu dia, you tak nampak beza brightness pun, dah tepu. Okay, so that is what I'm going to do. So the program is going to be very simple. Kalau I nak buat program dia, quite simple. So ni I nak kawal merah je merah dekat pin 11 betul? 11. So pin mode, double check merah you kat pin 11 ke? I punya kat pin 11. I type satu tangan ni, so lambat sikit. Pin mode pin 11. And what I want to do is control the brightness. Gelap, lepas tu terang sikit, terang sikit, terang sikit, terang sikit. Alright, so I akan guna arahan dia. Arahan dia, kalau nak kawal analog output adalah analog right. As simple as that. So kalau analog right hanya applicable kepada pin 3, 5, 6, 9, 10 dan 11. Pin lain tak boleh. Alright, so analog right pin 11, I nak start dengan kosong. I boleh sampai 255 maximum, tapi I nak ni sampai 50 saja. Right? Okay, I nak tengok dia nyala maybe around 1 second. And then I akan copy paste. I nak naikkan dia jadi 10. I nak naikkan dia jadi 20 sampai 50 lah. 30. So dia akan naik 0, 10, 20, 30 sampai 40 je lah. Tak muat screen lah. Lepas tu je. So if I were to upload this, okay, 0, 10, 20, 30, 40. Dekat 40 pun dah nampak, 30, 40 pun dah quite terang kan, betul? Boleh try? Very straightforward. Analog right 11, 10 and then copy paste. Right? Kalau I tambah 50 apa jadi? Ada beza dengan 40 tu. Dia dah saturated. The word is saturated in English. So now you bukan letak low atau high atau low, you letak value of 0 to 255. The higher your value, the higher the rotation you produce. The formula is times 0.01956. Okay? digital output, analog output. Kan? Okey ke? Kalau you letak you punya merah dekat pin lain, pakai pin lain lah. Kan? Janji pakai pin PWM 356 910. Jangan pakai pin yang bukan PWM, it will not work. It will not work at all. Okay? So digital output, analog output. Dua cover. Lepas ni digital input, analog input, and then finish. Okay? Okay, done? Done, okay. Right, nothing special So, I just want to show you something. Kalau you nak nampak dia, ini tak payah follow lah. Ini just for you to just appreciate what is happening. For you to get a very smooth increase and decrease, you kena increasekan dia 1, 2, 3, 4. Sekarang dia akan increase, you nampak dia 10, 20, 30, 40, betul? Dia quite staggered, right? If you want it to nampak dia increase slowly kan, then you kena pakai for loop lah. Ataupun kalau you rajin satu, and then apa? 2, buatlah sampai 50. Kalau you sanggup lah 3, 4, 5, 6, 7, 8 then you nampak dia smooth naik and then smooth turun. Betul? Delay kecilkan sikit supaya dia smooth naik dan smooth turun. Kalau you sanggup lah. Okay? Tapi semua tak sanggup kan? Right. Yeah, I just double check. Okay, it's already 11:30. So I need to basically hurry this thing out. Okay, so that is digital output and analog output. If I want to basically make it a smooth transition, right, then I will use a famous C function called for loop. I can basically do something like this. So just look at it. You don't have to do it. I create an integer. For I start with 0. As long as I is less than 50, I'm going to I plus plus at every single loop. Okay? So I start with I is 0. As long as I is less than 50, every single loop I will increment I by 1. 1, 2, 3, 4, 5. As long as it is 50. So then I will basically do something like this. Analog right. Okay, pin 11, and this is going to be I. And then the delay, I'm going to build a delay that is not that quite fast. Okay, and then done. So what is happening here is the first run, I is going to be equal to 0. I is going to be equal to 0. Is it less than 50? Is 0 less than 50? Yes. So yes, it will plus 1. So the next time it loops is going to be plus 1. This is going to be 1. Right? So 1 is less than 50, yes. So this one is going to be plus with another 1, increment by 1, so it will become 2. So it will loop until it reaches 50. Okay, so this is where you will get something like this. Okay, a pulsing LED. Right, a pulsing LED. Okay, and you want the pulsing LED to pulse up and pulse down. So this is 0 to 50. I can basically make it 0 to 50, and then I start at 50. As long as it is more than 0, I start to minus. So this one is going up from 0 to 50. This one is going down from 50 to 0. Right? So when I run this, basically I will get 0 to 50 and then 50 to 0. 0 to 50 and then 50 to 0. Something like this. Okay? 50 to 0. 0 to 50, 50 to 0. 0 to 50, 50 to 0. Siapa yang ada sakit gigi jangan tengok benda ni. Dia berdenyut, dia tu lain macam. Benda merah lah tu. Alright, so as simple as that. Okay, so depends. Okay, so done. So I'm going to go into digital read. So I'm going to digital read. How to read from a digital signal. Okay, so this is a switch. This is a switch. If I press this switch, then basically it will give out a signal. So the electronics is very straightforward. Let me just show you the electronics. So a switch is just two metal cap apart. When you press on this, these two metal will be shorted. Dia akan bersambung. Okay, so what we will do is that kalau output tadi Arduino keluarkan 5 volt, input pula Arduino bila dia accept 5 volt, they know that the pin is high. So what we will do is we have 5 volt here sambung pada pin ni. So bila pin switch ni ditekan, 5 volt ni akan mengalir ke dalam pin Arduino. Okay, so when you press the switch, Arduino akan terima 5 volt. When you don't press the switch, Arduino tak akan terima 5 volt, akan terima 0 volt. Right? So when Arduino terima 5 volt, apa yang you nak berlaku? Kalau Arduino terima 0 volt, apa yang you nak berlaku? Then you will come across the most famous coding dalam C, which is the if and else. If the pin is switched on, then what you want to do? If the pin is switched off, then what you want to do? Right? So you have three pin dekat switch. I would not masa sudah singkat. So you have 3 pin. Satu supply here on the top here is supply. Okay, so you have pin for supply. You have pin for ground. Whenever you have supply, mesti ada ground. And you have another pin yang akan pergi ke Arduino. Okay, so I pasang ni 3 pin. Okay, 1 pin is going to 5 volts. One pin is going to atas Arduino tu ada 5 volts. One pin is going to ground, and the pin that I'm going to read is pin number 2. I can pilih mana-mana pin. Let's say I pilih pin number 7. So this is my switch. 3 pins. Okay, 1, 2, 3, 5 volt, ground, and pin number 7. I masukkan pin number 7. Alright. So kalau you kena construct sikit jadinya. Kalau you guna modul, straightforward lah. Right. Kalau you guna modul, straightforward. Okay, so let us then decide. Kalau I press the switch, I will turn on the LED. Kalau I don't press the switch, I will turn off the LED. Okay, ataupun I will write in a serial monitor. I can write serial monitor, priest is switch, priest is turn, press. Kalau I tak press, switch is not press. I can keluar dekat serial monitor. Okay, so let us look at the program. I'm going to just show you this. Pasal I nak masuk IoT before we go. So new one. Let's say I make a new one. So kalau ada soalan you tanya. So I need my void setup and then I need my void loop as per we have discussed. Now I'm going to use pin number 7. Betul? I cakap tadi pin number 7 Pin number 7, I'm using it as an input because this is now a switch. This is now a sensor. So I'm using it as an input. Alright? So how do you read from the pin? I'm going to create a variable. A variable is a container where you put your answer in. Dia bekas untuk you masukkan maklumat dalam dia. So I want to put in the status of the switch pin dalam variable ni. So katakan I bagi nama variable ni Swiss. Kenapa I panggil dia integer? Because kalau on tu high, kalau high tu 1, kalau low tu 0. It is still an integer, 1 or 0. Alright? So Swiss, and then I baca digital read pin number 7. So whatever I read from pin number 7, semicolon, I masukkan jawapan dalam Swiss. As simple as that. Alright? So now I have my answer in Swiss. I tekan high, 1. Kalau I tak tekan, 0. Tekan 1, tak tekan 0. Alright? So let's say I'm going to show this on the serial monitor. I said the USB boleh send data daripada Arduino ke laptop kan? Right? So I'm going to activate the serial communication. I want to activate the serial communication to look at the status of the pin. Right? So what I need to do untuk initiate the serial com, I need to basically turn on my serial com by giving the instruction serial.begin. I will open up my serial com. Right? And this is going to be the protocol. Right? 9600 is how many bits you transfer per second. This is the baud rate, they call it. You can put a higher speed, no problem. You boleh sampai 112,600. But normally people will use 9600. Right? So this is just to set up your serial com, make it turn on. Dia dah turn on. So now I want to straight away print serial.print. I want to straight away print the status of my pin. Serial print line new, LN to line new, line baru. Okay, and I want to straight away print my status of the switch. Betul tak bila I tekan dia 1, bila tak tekan dia 0? Betul tak benda ni? Alright, so I upload. Jadi kita tengok, senang je. I baca pin and then I print dia, tengok jawapan dia apa, status dia apa. Alright, so baca the pin, simpan jawapan dalam Swiss and then I print the Swiss status. Right? So bila I run, because dia ada serial monitor this one here is serial monitor. So turn this on. Okay, kalau you tengok tak keluar apa-apa. Pasal apa? Perasan tak bawah ni baud rate dia berbeza. Bawah ni tengah tulis berapa sekarang ni? 115200, nampak? Baud rate berbeza. Saya set tadi baud rate berapa? 96. So I kena tukar baud rate ni supaya dia matching. Kalau tidak nanti ayam bercakap dengan itik. So I kena cari yang sama, 9600. 9600. Okay? I tak tekan kosong. I tak tekan. So bila I tekan 1. Tak tekan kosong, tekan 1. Tak tekan kosong, tekan 1. Okay? Okay, so let's make this much more interesting. let's make this much more interesting. Dengan kalau I tekan, dia akan tulis kat situ Swiss ditekan. Kalau I tak tekan, dia akan tulis kat situ tekanlah saya. Okay. So I akan buat something like this. So I akan gunakan the most famous function in C programming, which is the if-else. If Swiss equal to high, if the Swiss is equal to high, this is a function. Function you tengok tak ada semicolon, and function start with the curly bracket open and close. Alright? Okay, function is always like that. Okay, so here kalau Swiss ditekan, what I want it to do, I want it to serial print. Swiss telah ditekan. So I'm writing a text. Swiss telah ditekan. So I'm writing a text. Okay? Else I copy this. Okay? Tekanlah saya. Something like this. Okay? So if Swiss ditekan, it will run whatever inside here. Kalau Swiss tak ditekan, it will run whatever inside the else. You nampak tak buka dan tutup dia tu? Dan you nampak tak buka dan tutup dia tu? Now you appreciate that these are the pagar dia, the start and the ending of the function. Right? So if I run this, okay? So if you have more than two conditions, this is two conditions, if else. If you have more than two conditions, if, else if, else if, else if. Okay? So uploading. So now if I run this, tekanlah saya. Right? Tekanlah saya because now the Swiss is low, correct? It's always going to go to else. Betul? Only when you tekan Swiss jadi high, baru dia akan display Swiss telah ditekan. Okay, so bila I tekan, Swiss telah ditekan. Tekanlah saya, Swiss telah ditekan. Tekanlah saya. Okay, if you want to add another output, then let's say you nak nyalakan lampu pin mode, kita nak gunakan pin 13. Pin mode pin 13, kita jadikan dia output. Kita nak nyalakan LED. We want to turn on the LED whenever the Swiss is high. So here we straight away can put the right pin 13 to be high. Kalau Swiss tak ditekan, I can straight away write the right pin 13. I'm going to set it to low. So if I run this, now if Swiss is high, pin 13 will turn on. Okay? And serial print will print Swiss telah ditekan. So it will do two things. It can do three things, four things. Whatever you put inside the bracket, it will execute whenever you press the switch. Okay? So now done uploading. So now you can see my LED over here. If you can see, it will turn on as well. Okay? It will turn on as well. Okay? Alright? So simple as that. So that is digital input. Analog input is going to be quite a lot more interesting because it is not 1 or 0, it's not high or low. It has a range. For example, untuk analog output tadi 0 ke 255, betul? Kalau untuk analog input, you ada sampai 0 ke 1023. You ada 0 ke 1023. Okay, if I can straight away look something like this. Okay, so this is a light sensor. This is a light sensor. The light sensor has 3 pins as well. Ada 5 volt, ada ground, dan ada signal. Every single module is the same. is the same. You ada 5 volt dengan ground untuk supply dia, and then you ada signal output dia. You kena tahu sensor tu digital ke analog. Kalau digital masuk pin digital, kalau analog masuk pin analog. Alright, so this is an analog LDR module. Tinggalan mata. Bantu ya. Someone with a good eye. I got a very bad eye. VCC. Which one is the VCC? The last one. Okay. Put in the never mind. And then put in the ground. Okay, and put in the AO. Alright, so the white is AO. So the white is analog output. The brown, is VCC. Black is brown. Alright, thank you very much. So now, because my eyes is 46 this year, so rabun. Okay, the same thing. Supply ground dengan signal sama je, but now is analog. Analog you have 0 to 1, 0 to 3. So let us look into this. So analog, the only difference is that straight away I don't need my pin mode, because analog pin is analog pin. Dia tak ada bidirectional, dia tak ada pin mode. Okay, my analog pin, let's say I change this to light. This is light, okay. And then the pin is A0. I masukkan dekat A0 dekat on my Arduino A0. So now it is not digital read, but it is analog read. Okay. So what I want to do now is I'm going to serial print. I'm going to look at the values. Serial print light. So serial print light. So I'm going to run. So now this is an analog sensor. Okay, the value is not going to be 0 or 1. Okay, so let us discover what is the lux or light value in this room. Okay, so now ambient light, room light is 200 something. Is 200 something, right? The coding is very straightforward. The coding is very straightforward. Analog read A0 and then I print it. Itu saja, right? So now this light in this room now is 270. Maximum is 1023. So if I were to then close, it's around 800. Room light is around 200. If I were to close the sensor up, total darkness is around 700. Okay. If I were to use my torchlight, it's going to be, the closer I get, the smaller the value. You see? Okay. The higher the value. So the room light is around 200 something. If I were to close it, then 700. So now you can make a if else to detect whether a torchlight is being shined on it, whether you are closing it, or whether it's a room light. So there are more than 2 conditions over there. You can make if, else if, else if, else if. Alright? So analog sensor can give you a lot more variety. I have with me temperature sensor, light sensor, force sensor. Force sensor maybe is a little bit more, you will use it more, maybe. Right? Force sensor in your mechanical project, things like that. Speed sensor, accelerometer sensor, RPM sensor for your motor. Okay, so a lot of other concept things there. But analog value like this, you can have a variety of range. It's more sensitive. It's not on and off, switch high or low and things like that. Okay, right? So those are the four basic, basic skill that you need. How to read from a digital input, how to read from analog input, how to control analog output, and how to control digital output. Okay, right? So that will cover. It's close to 12, Okay, so that is covering everything in terms of that. But I did not show you properly the if else and things like that. Okay, but what I want to just steal a little bit of time, maybe around 10 minutes, 10 to 15 minutes, if that is allowed. So I need to steal 10 to 15 minutes for me to show you IoT and how simple IoT is. Right? Okay? The normal Arduino doesn't have a Wi-Fi, so I need a special board to have the Wi-Fi. So this is a Node MCU. So this is a Node MCU that basically will give me the Wi-Fi. Right? And the most important thing with IoT that I have to explain to you, the most important thing with IoT that I need to explain to you is that you need to connect it to a Wi-Fi that has no login page. You need to connect it to a Wi-Fi that has no login page. Only semua ada login page kan? You cannot do that. Dia cuma you connect to a Wi-Fi yang pakai SSID and password. Finish. So what I will do is that I will create a hotspot in my phone, so it will connect to my phone hotspot. Okay, right? So you cannot connect the IoT project to a login page Wi-Fi hotspot. Right? So remember that. It will not work. Okay, so I'm opening up my mobile hotspot. Alright. So the most easiest coding, the most easiest IoT concept to use is the blink. Is a blink. Okay, so blink ni paling simple lah, paling ramai orang guna. Right, it's very straightforward. It has a wizard yang basically allows you to connect in 5 minutes. So you see how easy it is for me to connect. So I need to turn on my Wi-Fi also for here. Disconnect. Alright. Okay, so I'm going to use blink. Blink. So this is blink. Okay, and you can create basically a very simple IoT dashboard in 5 minutes. Okay, kalau you nak apa, basically time me, you can time me. But obviously I'm describing it as well, so it's going to take more than 5 minutes. Alright, so connected. You can go, when you go to blink, it has a quick start. When you go to blink, it has a quick start. So I can straight away here go quick start. Okay, so quick start, you need a hardware and you need an Arduino IDE. Okay, so here I have already my hardware and I have my Arduino IDE already installed, correct? Okay, so I can straight away, let's go. Okay, I'm using ESP8266. It's either you are using ESP8266 or ESP32. Itu je dua yang you akan guna. Dekat Malaysia ni itu dua je yang you akan guna. Definitely you takkan guna yang lain-lain ni, jarang. Right, it's either 8266 or ESP32. Depends on your hardware. Okay, I'm using 8266 and I'm connecting to Wi-Fi. Next, I'm using the Arduino IDE. Right, next. Okay, so I've already installed the Blink library for my Arduino. Okay, so if you haven't installed, you need to install the Blink ID for Arduino. Okay, go to Tools, Manage Library, and then done. Okay, again, next. Okay, here is the code for your device. They bagi you code for your device. Straight away, they bagi you code for your device. So you need to just copy the code. Before you copy the code, you kena masukkan you punya SSID dengan password. So dia akan your microcontroller will connect to this Wi-Fi. So that is where you cannot use a Wi-Fi that has a login page. You cannot use a Wi-Fi with a login page. Okay. So my SSID is Zulida. My password is jangan connect dengan ni kan berat ni. UGVD 7. Okay, so now done. I'm going to copy the code. So now the code has been copied, and I can straight away basically go to my Arduino, open up a new sketch, and I can straight away, I dah copy tadi kan, I can straight away paste. So now my coding is there already. My coding is done. So here is my SSID and password yang I dah set tadi. It's done. Right? So I just need to do a couple of things over here to make it work. Right? Okay. So done. So I can then basically go to Tools, select my board. This is going to be ESP, not MCU. Okay, port is 24. Upload. So I'm going to upload. I'm going to upload the program. It's going to be a little while because the program is very huge. Okay, it's going to take around 2-3 minutes longer than normal. Okay, so compiling, blah 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 blah. You can see that it will take a little bit of time. Compiling. Okay, so that is what it meant by 5 minutes. 5 minutes for you to basically have IoT. And then use your knowledge of your Arduino, analog write, analog read, digital write, digital read to code your microcontroller to control actual devices from the internet. From the internet itself. Okay, so now connecting, writing 50%, writing 20%. So you have to reach until 100%. So you do not do, you cannot see this in normal coding, correct? You only see this when you use IoT devices. Okay, done. Then let us look at the serial monitor. I think it's 11520. Okay, so ready. Connected to Blink cloud, ready. So yes, it is now connected to the cloud. So my device is now connected to the cloud. So if I open up the hardware here, then your device is online. Time to push some button. Right? Okay, so I can go to device. So now it will open up here. Quick start device. I have a couple of buttons already here. Okay, that I can play around with. Okay, so I can choose to basically go to my template, quick start device. So I can design my web dashboard over here. I can design my web dashboard over here. So here is the on and off button. So this is a virtual button V0. Data stream switch control V0 is here. Okay, V0. So what I can do is I can go to my coding This is V0, correct? This is V0, correct? Blink right V0. Okay, so what I can do is, in void setup, I can put in pin mode, which pin that I want to control. Okay, let's say I want to control red. Man, I need to wear my glasses. Tolong. Come on. Mana kau? Alright, so I'm going to use a pin. Okay, this is a little bit. I need to refer to the data sheet. This one. So I need to know the pin. So I'm putting it into pin 5, GPIO 5 here. General purpose input output 5. So I put it into pin 5. So what I need to do is in Arduino, this sketch, I need to make sure that pin 5 and tell it to be an output. So pin 5 is an output, and in the virtual here V0, okay, what I need to do is I'm going to write digital write, similar as before, pin number 5, but the value will come from the internet. The value will come from internet. So pin 5, here I'm going to put in value. Okay? So what this will do is that the virtual pin 0 basically will turn on pin 5. So I connected to pin 5 to this LED here, right? So it will turn on and turn off automatically. So I need to upload this one. Okay, so I just add on setup pin mode, and then I just add on the digital write. Now I can control my pin through the internet. Okay, uploading. Okay, 7, 15, 23, 30, 38, 46. All right. Done. Okay. It's already been. Okay, now here I can basically go to the device. Okay, now online, if I turn on this switch, now this switch is in the internet. This switch is in the internet. So if I turn on this switch, it will turn on. So if it is not turned on, then manulah. Okay. Switch is 0. Dia padam ke nyala? Switch is 0, padam. Switch is 1. Okay, as simple as that. Okay, kalau I nak tambah lagi pin, I just show you I tambah lagi pin. So what I need to do is, kalau I nak tambah pin, I pergi balik for my template. Data string ni I akan tambah edit. I add a new data string, virtual pin. So I nak kata ni LED, my LED number 2. LED number 2, pin V4. Okay, pin V4. And then it's going to be integer 1 or 0. 1 or 0, 0 mean max 1, and then I create. So now I have created LED 2, the second LED. Okay, so I go to my web dashboard, I select a switch. Okay, I select a switch. Now this switch I can basically give it a title. This is my LED 2 switch. I choose a data stream. It is coming from V4. It's coming from V4, 0 or 1. Okay, right. Show on and off value. I want to show it. Label position right. Okay, so save. So now I have V4. Okay, so now what I need to do is I need to connect my hardware. So I will connect my hardware to second pin. This is pin 4. Or I'm using pin number 16 lah, 16. Pin 16. Kan kat sini I tak nampak lah. Ni ujung sekali senang nak cucuk. Okay, pin 16 I add on to this one. So I pin 16 I add on to another LED. Done. So I need to go to my software. Over here I need to then add pin 16. Copy and paste. So now pin 16 also becomes an output. Alright, and then I will have to create a new blink right. Create a new one, because now this is referring to V4. V4, that is the virtual pin V4 that we created. So now virtual right, digital pin 16. Okay, pin 16. So upload. So now I can control 2 pins. V1 ni refer to switch punya condition yang dalam web page tadi. Yang ni V1 tu I tak tukar pasal ni, yang ni. This is V1. So dia display condition here and here. I should add another condition here so that it will create V7 lah pula. Should be like that.
And what is totally for the dashboard?
Yes. Yeah. Okay. Dah done ke belum? Done. Okay. So done. I can go to my device. Save and copy. Oh, I can save dulu. Save and apply. Okay. Go to my device. Restart. So now this is my device. So I have two LED 1 and 2, correct? Online. Okay, this will turn on the first LED. Turn on that. Turn on, right? And this will turn on the second LED. Okay. So this will turn it off. This will turn it off. Turn it on and turn it on. Okay. I can also straight away go to my handphone. I can also straight away go to my handphone and create the app. I can create the app. Okay. So in my handphone, tak nampak oh boleh nampak ikut sini kot. Juga. Buat family pula bro. Okay, in my handphone, I ada screen mirroring tapi tak ada pakai tu. Okay, in my handphone, I have the Blink software over here, apps. I can open up the Blink apps, and you can see the quick start device is there. The quick start device is there. Okay. So I can go to the quick start device, and then now I can basically control it here as well. Ada on tu kan? So I can basically turn it off here as well. Off, on, off. Okay, I can control it here as well. Kat sini pun I can basically create more slider, button, everything here. I can create my apps as well. So both, I can have my web console and I have my apps console. Right? I can have both. Okay. So this is being done in what? 5 minutes? What I didn't show you is how to then display temperature measurement, display light measurement over here. Okay. So as you can see, you can control IoT in 5 minutes. Alright. Okay. Benda lain tu sama je. Digital write, analog write, digital read, analog read, sama je. Yang lain tu sama je. It's the same thing. You ada if, else, whatever, dan anything like that lah. Okay. Alright. So this is your widget. Katakan I nak tambah pin satu lagi ni kan, satu lagi button kan. So I tambah satu lagi button, nampak? Kat sini ada button yang I tambah. And then I can set the button. I kata button ni switch, select data stream. Data stream dia LED 2. Data stream LED 2. Select, push. Okay, then done. So sekarang ada ni on. Sekarang tengah on ke? So kalau I tekan off, dia akan off lah. Off. On. Off. So I ada dua button lah. Ni pun ada, ni pun ada. Okay. So as simple as that. So I hope you have a lot of ideas to be done. Tapi janganlah tambah IoT tu semata-mata nak tambah IoT kan. Projek you adalah keropok lekor machine. Nak turn on kena pakai internet. Semata-mata you need to find the reason why you need to do it in terms of IoT, to justify the use of IoT. I jumpa 60 to 70% electronics project dia tambah IoT semata-mata because nak tambah complexity of the project without any purpose at all. Right? That is very important for you to take into account. Use IoT with rationale, with proper rationale behind the use of it. Okay? Contohnya dia nak turn off kan lampu rumah dia ke, bila dia pergi melancong ke apa dan sebagainya lah, whatever lah kan. Whatever that you can think of, that will justify the use of IoT, right? But again, when we talk about devices, not MCU yang I pakai ni, this not MCU yang I pakai is only RM20 plus, RM30 plus. So it's very cheap. And you boleh pakai hotspot you sendiri, and then you can try it. Okay? So that is what I have for you today. I hope that it can assist you in your FYP and have an idea of what you want to do in the FYP. As I said in the morning, the things that you do not know is what makes you basically afraid of trying it out. I hope that this could give you a little bit of motivation or bravery to try and look at certain programs. Yeah.
Sir, kalau sistem yang simple macam kita tunjuk tadi yang tiga sensor dengan reflektor tadi, berapa pun?
Cost. Macam sensor lampu ni RM2. Sensor temperature you can get, yang bagus pun you can get RM8. So very cheap lah, under 100 dah you dah boleh ni. Yang buat mahal selalunya macam mechanical part. The electronic part is nowadays very cheap, very cheap. Melainkan saya tak nampak lah. Yang mahal pun kalau you nak industrial level sensor lah, then that is expensive. Industrial level sensor, color sensor, then that is a little bit. Kadang-kadang mechanical akan nak guna color sensor, nak detect objek warna kan, pushkan hijau ke one box, merah ke one box. That is a little bit expensive. Itu je lah. Yang lain semua electronics is under, sekarang ni under RM100 dah boleh dapat. Alright. You all ada budget untuk buat projek ke? Ada? Tak ada? Kau sendiri
Dia own.
But one project is 2 person? 3 should not be a problem. 3 should not be a problem. You want to justify the 3 with the level of the project, itu problem. Betul. Ya betul. Kadang-kadang Itek akan tengok 3 orang buat projek. Kan. That is difficult part. That is the difficult part. Okay. So thank you very much. I guess I've taken your time extra of about close to 30 minutes. Sorry about that. I hope this is not the first and the last time you see me. If you have any question or whatsoever, you can ask. No problem. Okay. Good luck for your FYP. Okay. Thank you very much. So I'll pass back to the committee.
Okay, ni yang dia buat ni dia panggil 3D Faham?
Lepas ni tak ada pun. Esok
dah tak
ada
ada
post
soalan.
Ha?
Yang lain-lain
Esok ada postmortem.
boleh start kemas lah.
Potong buat
Postmortem.
Habis.
buat.
Okay,
macam
terima
review lah,
kasih
tengok
kepada
dah buat apa,
Pelajar
ada masalah
atas
ke
komitmen anda.
tak, everything.
Abang mengucapkan selamat berpuasa dan selamat menyambut Hari Raya Aidilfitri tak lama lagi.
Kehadiran.
Okey, minta maaf atas kekurangan gurauan dan sebagainya hari ini. So kalau ada apa-apa boleh just text saja Don't worry. Okay, thank you. Assalamualaikum dan selamat tinggal. Bye.
Iman.